Hello world, this is CS50 on Twitch. My name is Colton Ogden, and today we're going to journey back into game development. The last few streams have been sort of catered towards web, and actually David and I did one on the CS50 sandbox yesterday. So if you're looking for a quick way to spin up a coding environment in the web browser, go to sandbox.cs50.io. Super awesome website that we talked about yesterday. So today we're going to go back into game development. The last game that we did actually was Minesweeper, I think, which was, I think, over a week ago. It might have been 2 weeks ago, actually. We've been doing a whole bunch of different stuff, actually, a lot of web development. But indeed, we're going to go back into games today. So I'm going to switch over to my computer here. We're going to be using Love2D. So if you're not familiar with Love, it's an awesome 2D game development framework. You can go to love2d.org and download it for your operating system. They have quite nice availability if you're on Windows, if you're on Mac, if you're on Linux, and some other operating systems. We've done a lot of streams on this in the past, so definitely check out our prior playlist on other games. Minesweeper was the last one. We did that in Love2D as well. Today, we're going to be doing a card game. We're going to be taking a look at Solitaire. And I thought I would pull it up here just so we can see what it looks like. It looks something similar to this, where you're essentially given a deck of cards, a standard 52-card deck. You have normally 7 piles here, which are, I don't think the technical term is tableau. I think tableau refers to the portion of cards that you have actually revealed and set on a given row, or a given column in this case. And then you have the 4, what are these called? I forget what the exact name of these is called. Do you happen to know, Ian, what the name of these is called?
No, I'm not sure.
The 4 sections. We're joined today by Ian in the back, who's kindly helping us get everything set on all of our platforms. But the goal is to basically fill these 4 sections of the top of the board with all of the cards ace to king of the different suits. So you can see there's hearts, spades, diamonds, and clubs. And if you're unfamiliar with sort of how cards are laid out, you start with ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, and then king. And that's the sort of sequence of cards, and all the cards are also given a suit. So you get all of those sequence of cards. In addition, they have a suit of hearts, spades, diamonds, and clubs. And essentially, your goal is to get all the cards there in order. But in order to do that, you can lay them out here in reverse order, starting with the top card, the king card, going down to ace. And once you have all your cards sort of laid out in this way, it's very easy to take those cards and then sort of lay them out in that sort of ascending order at these top level here. For example, this 4, I can easily just bring over, if I had the 3 of hearts here, I could bring that 4 of hearts more easily to the top than if it were in sort of descending order, or rather ascending order, laying from the king downwards, or from the ace upwards. So thanks to everybody who's been in the chat here. I have the dialogue here open. Jeans0022 saying, big up guys, you're doing nice work, keep it up. Very much appreciated. Andre's here in the chat. Bellacure's Crazy Flock. Shalene, I presume this is a Lua Love2D stream. Are you using any Love2D libraries like LoveFrame, or is it just going to be done from scratch? Excuse me. And I just realized, I apologize, I had the chat visible on the screen there. But we are not going to be using any library. Well, that's not true. We will be using some libraries. We'll be using the class library from Helper Utilities for Maximum Productivity, which is an unfortunate acronym. I brought this up on multiple streams. You can look that up. So if we go to class, Helper Utilities, Lua, Love Helper Utilities for Massive Progression. Sorry, Massive Progression. And they have a class.lua here. So you can go visit this URL if curious. I can actually plug it here in the chat. Unfortunately named, but that's just part of the Lua ecosystem. It's a very good set of libraries. I highly recommend using it. We'll be using that for object-oriented programming in Lua. When we've used this on prior streams, but if you're unfamiliar, object-oriented programming basically lets us, instead of using raw numbers and tables and those sorts of variables, we can actually model things like cards and decks and all sorts of other more complicated objects that we wouldn't traditionally be able to get with the language sort of as it comes, the standard language. Shalene saying, gotta love all the Love2D library names. Yes, indeed. Some very funny named libraries. Awesome. So thanks so much, everybody who's here already. I'm going to go ahead and just shift this Twitch over here, or shift the chat over here. Let's get started. So we know the rules sort of at a glance. We can see that we're going to be using cards. So we're going to need some way to sort of have cards that are visible in our game. So for this, we're probably going to need some sprites. So we can go to something like opengameart.org, for instance. I'm going to go here. Opengameart.org is an awesome website that I use in the games class that I teach. So this is cs50.edx.org/games, which will allow you to go and learn game development from the beginning. So you can learn Pong. We go up to Flappy Bird, Match 3, Super Mario Brothers, all the way up to Unity stuff, actually. And in that course, we end up using a lot of opengameart.org stuff. Excuse me for just 1 second. Let me make sure everything is OK. I apologize. Let me just make sure my mic is good on battery, but I just want to make sure that it's 100% OK for the rest of the stream, because this one's going to run a little long. So give me just a second. You might hear me cut out my audio. All right, we should be back up with a fresh battery. So awesome. Want to make sure we don't die suddenly on stream and everyone's wondering why I'm completely gone quiet. Awesome. So David's in the chat. Everybody, shout out David J. Malin, who did stream yesterday on the Sandbox, CS50 Sandbox, which sandbox.cs50.io. If you're curious, allows you to spin up a temporary programming environment from scratch, which has a lot of awesome pre-installed languages and environments and libraries and stuff. So definitely check that out if you didn't watch yesterday's stream. And if you haven't watched yesterday's stream, definitely do so that you can get a sense of just how it works and the things that you can do with it. So opengameart.org, as I was saying earlier, is a platform, a website that has a bunch of completely free game programming artwork, sprites, and 3D models, and also things like audio, which can be kind of important too. If you're not a sound designer and maybe you want some free audio assets, you can definitely check that out. But what we want to do is, I don't want to make a bunch of cards from scratch, because when we did Minesweeper, I ended up doing a bunch of sort of making mines from scratch. And that was OK. It was a pretty simple set of sprites to develop. But cards are a little more complicated, and they all have suits. And I don't really want to be bothered with actually making it. And I kind of want to make it look nice to begin with. So I know that there is a pack of nice-looking cards that we can use here. So if I go over to, I'm going to type casino. I ended up looking at this in advance just to sort of pre-curate the kinds of art packages that we might want to use. There's a nice package called Board Game Pack by Kenny. And actually, Kenny is a artist that I use a lot in the games course, who kindly makes a lot of his artwork available here for free. So I'm clicking on the Board Game Pack. And this, I think, is actually a fairly high-resolution piece of artwork. Yeah, there are 68 playing cards. They don't necessarily specify the resolution here, but I'm just going to download it. There's a link right here. Most of the artwork, as I said, on this web page is very kindly made available. In this case, you can see right here the license is public domain, which is really cool. And to answer Great Baram's question, what's the topic? Today we're going to be implementing the game Solitaire. So you can see here, if I go back to this page, the game Solitaire is kind of a classic card game that was popularized in the Gold Rush age, sort of in Canada and America back in the late 1800s. But essentially, it revolves around you getting a deck of cards. You lay out a bunch of cards sequentially, starting with 1 card, 2 cards, 3 cards, 4 cards, most of which is actually unrevealed at the start of the game. And your goal is to get essentially, whoops, that was an accident. Your goal is to get all of the cards in the deck from ace to king up here on these 4 sections. And they're all suited too. So you get ace, you get your hearts cards, your spades cards, your diamond cards, and your club cards. Another important thing too, actually, is as you're laying cards out in these stacks here, where you're trying to lay them out sort of in a descending order, where you start with king and go all the way down to ace, you want to make sure that they're all in black-red order. So notice here in this particular area, you can see that it goes black, red, black, red, black, red. So king, queen, jack, 10, 9, 8. So not only do they have to be in descending order, proper order, but they also have to be cross-colored. They have to be in a pattern, that sort of pattern. And you have 7 sort of sketch areas, I guess you could think of it as, in order to lay things out. And they're called the tableau, is the term, I believe, for the set of cards that you've laid out in any one of those given stacks. All right. So let's go ahead and check on that pack. Let's see what we have to work with. So we're going to download these assets. We're going to get a bunch of folders here. So I'm going to look probably in the PNG folder for the cards. And the nice thing is they actually give it to us. They give us card backings as well, which is nice, because we will need to show some of the cards as hidden. We'll see. Let me see if I can actually pull up an example of what the Solitaire deck looks like when you first start out. The Solitaire starting layout. So this is great. So this is exactly what it looks like when you first start out. And this is actually playing a version where you lay 3 cards out at a time from the deck. And we're just going to be doing 1 card at a time, which is more of the Windows version of how it's implemented. And also a little bit easier to win. I think you have a 90-something% chance to win as opposed to a 75% chance to win. But these are the 4 decks where you're supposed to lay out your cards from ace to king in the different suits. These are your sort of starting staging areas, and this is all completely randomized. It's all drawn from the deck. You start off with 1 card face up. Then you start with 2 cards, the top of which is face up, and the rest of which are face down. The same thing happens here, then here, then here, then here, then here. You only get 1 card face up. All the rest of the cards get face down. And then here's your deck. And then here's the 1 card that you get to draw from the deck at a time to place down either on any one of your staging areas, or if you happen to get an ace, or if you've laid an ace down and maybe you have laid down some other cards in your 4 sort of deck areas, you can place the card there. And we'll sort of see how the rules work out and mess around with it. But this is the starting layout. This is what it's going to look like. And as you can see, per what my prior note was, we are going to want to display cards that are face down. So not only are we going to want to show face up cards, but also have a card backing so that we know we're drawing a card or we don't know what the card is yet. So kind of an important consideration. Let me go ahead and check back on that. So if we go over here, I can see we have all the cards, the individual cards, which is great. So we will want that. We can see that they're numbered or labeled in a pretty consistent way. So we see card clubs 2, 3, 4, 5, down to ace, jack, king, queen. It does the same thing for diamonds and hearts and spades. So that's great. The resolution of these is, it's not showing because my Finder window is too small. So 140 by 190, which might be actually a little bit too big. Especially if we're running it in 720p. We might want to end up downscaling a lot of these, excuse me. And actually, are we given a sprite sheet? We are given a sprite sheet. So let me see, do we have the cards laid out? Playing cards.png, which we do have a sprite sheet here. It's 1024 by 2048. So if I load up the sprite sheet, this is an important thing you want to consider. First of all, using sprite sheets is generally more performant than loading individual textures because your graphics card only needs to reference 1 file instead of multiple files, multiple locations in memory. This is also a lot easier if you want to, for example, downsize this. So maybe I want this to be smaller. Rather than scaling it in hardware, I can instead just pre-downscale everything and make a smaller texture. So we can definitely do that. And I think that's probably what I'm going to end up doing. So this is 1024 by 2048, it looks like. What I can do is load this up into, well, first of all, let's set up our project, and then we can worry about all of that. I'm going to create a new Finder window, going to set up my project, go to jharvard, dev in this case, over to streams. I'm going to make Solitaire. I'm going to load this into VS Code. And let's make sure this is blown up so it looks nice. I'm going to create a new folder. So this is my project folder. In Love2D, what you typically want to do is have a project folder within which there is a single main.lua file. And this is the entry point of your program, much like it is in, for example, C, where you have int main void. In Lua, you have a main.lua. So I'm going to create a main. This is a folder. First, I'm going to create graphics. Then I'm going to create, outside of graphics, a new file called main.lua, which later we'll fill with our source code. In advance, I know this is going to be a relatively not super complex code base, but it's going to have multiple modules. So I'm going to create a source folder, which is going to contain all of my Lua files in the future. And within graphics, this is the folder that I actually care about right now. I want to copy and paste from here playingcards.png. I'm going to bring it over to my graphics, paste that right in there. And then I'm going to open this in Ace Sprite, which is a graphic editor that I like to use, which has pretty good Sprite artwork support. And now what I'm going to do, I'm going to just kind of shrink it a little bit. I don't mind how it looks here, actually. You can see that I kind of zoomed out and gave it a more pixelated look. And so this is kind of a preview of what it'll look like when we actually downsample everything. And it looks OK, honestly. It doesn't look bad at all. So I'm not sure what the resolution is at this point. I think I subtracted it or I shrunk it down by half twice. So if I were to, let's say, sprite size, lock the ratio, let's shrink it down by half, right? OK, nearest neighbor filtering. And so this is actually what it looks like at native size. So it looks OK. It's not too bad. You might be able to make something work with this. Now, each individual sprite, so if we're at 512, we have a total of not quite, it doesn't quite divide evenly into 512. So 1, 2, 3, 4, 5, 6. So if I actually, maybe I crop it. Do I want to crop it? No. Maybe not. I think what I'll end up doing instead is just, because I think if we just use the algorithm we've used in prior streams, where we sort of go throughout the sprite sheet figuring out the size of the cards we want, and maybe actually don't even go through the entire sprite sheet, just extract the cards themselves and sort of forget that there's white space, it won't even matter too much. So in this case, we only really need to worry about how big each individual card is. We'll see this in code here in a little bit. But let's go back to the actual cards themselves, figure out how large they are. The individual cards themselves, oh, also another thing that I'm realizing here, it doesn't include the card backing in the sprite sheet. So we're going to have to load that texture separately. That's fine. It's not a big deal. It's only one individual sprite. Let's see. The cards themselves were 140 by 190. We shrunk it down by half, so they're actually 70 by 95 now, which is the one consideration we need to be conscious about is the fact that when we end up stacking things, we could have theoretically a deck that starts with that has 1, 2, 3, 4, 5, 6 blank cards, and then from king down to ace, that would be a total of, that's what, 13 cards? 13 cards plus 6 cards. So 19 cards times that by, well, actually, we're only revealing a certain small amount of the card. This is probably, what, 10 pixels, 20 pixels? I think we'll probably be OK. Let me make sure I'm keeping up with the chat here. Did you create the card sprites too, says Eln1? No, I did not create the card sprites. So we actually got, if you go to opengameart.org and then go type in casino, for example, it's called the board game pack. So actually, if you go to the opengameart.org/content/board game pack here, you'll find it. But it's a card pack, or a casino pack, generally speaking, by an artist named Kenny, who I actually really enjoy the artwork of and I use a lot in my games class. But he has a lot of different themed art packs. In this particular one, he happens to have a bunch of cards just like this. And I like the aesthetic. They downsample nicely into more pixelated artwork, so we're using that. And right now we're sort of figuring out how much we can downsample the artwork so that we can use it in a smaller pixelated game and have all of the cards visible on screen no matter what the deck size or the tableau size, which we'll look at. So we're just doing a little bit of preliminary investigation here. But I think we'll try this. We can always resample this. So I'm going to save this. So now we've shrunk it down by half effectively. And I'm going to go back into here. And we can see that now, instead of 1024 by 2048, it should be 512 by 1024, which you can see right here. So this should be a good size. And then we'll end up chopping this up into bits and pieces in main.lua, well, rather in a util.lua, which we'll implement again from scratch. Bavik Knight says around 4, 5, 70, 95. Oh, the aspect ratio? Yeah. On the cards, is that transparency going on with the checkers background? The checkered background? Where are we referring to? If we go back to Sprite. Oh, the checkered background. Yes. This is transparency. So anything that gets, if we were to import this in our Love2D game and render this just like completely flat, it would not render anything here, just the cards themselves. And I actually think that there might be a line of transparency, but I actually can't tell just by looking at it here. Well, we might end up seeing it once we end up loading it into our game. But yes, if you're in most 2D Sprite or artwork programs, Photoshop, GIMP, Sprite in this case, you'll typically see checkered background when you load in an image, and that just means it's completely transparent. If you were to draw that in your game, it won't draw anything. Oscar M says howdy. Hello, Oscar M. And then the True Kinese kindly plugged the link to the Sprite artwork. Cool. So let's go ahead and get a little bit of code up and running here. So I'm going to do just a little bit of the typical stuff as we're loading up a Love2D application so we can get up and running. We're going to call this Solitaire. I am the author. And we'll plug my email address in here. This is relevant for when I end up publishing this to GitHub, which we'll do. So eventually this will be downloadable. You can download this and test it on your own computer. I'm going to go ahead and do a few preliminary functions. We've seen these before, but if you're unfamiliar, these are functions that the Love framework expects you to have when you start your game. So love.load triggers at the very beginning. Love.update triggers every frame. Gets the amount of time that's passed since the last frame so that you can sort of calculate different frame rates or different speed computers, the same speed. You can have things happening at the same progress despite what someone's frame rate might be on their machine, which is very handy if you want this to be to perform consistently across hardware. And then draw does also operate per frame like update, but it doesn't accept any frame rate. This is just meant for just pure drawing. No changes necessarily to be calculated therein. I'm going to preemptively sort of get everything structured in a fairly robust way. So I'm going to say require source/dependencies. And this is important. I'm going to go over to my source directory here, add a new file called dependencies.lua. This is where I typically like to have all of my libraries and also all of my textures. So we'll do a little bit of testing here, just a sanity check, make sure everything's up and running. I'm going to go ahead and say gTextures equals a table. G meaning that this is a global variable. I should be able to access it from anywhere. This is a sort of a convention. I'm going to give it a name of cards, and I'm going to set it to love.graphics.newImage graphics/ and what is it called? Playing cards.png. So now this is available anywhere in my application. Typically, I like to do this. I like to have all of my textures, all of my sound files, everything all in my dependencies.lua. This is just a way of modularizing your code, sort of, I forget what the exact term is, but it's not allocation of interests. It's, there's somebody in the chat might know what it's called. But it's basically just making sure that all of the things that are within one domain get isolated into one area so that you don't have to go grepping through your entire source code repository to figure things out. So I'm going to go ahead in love.load. I'm going to say love.window.setTitle to Solitaire, just for quality of life. I'm going to actually implement another function here called love.keyPressed, which takes in a key. And again, this is another function called by Love, and it will call this, and it will pass you the key. But it's up to you to define what you should do with those keys. Separation of concerns, Light of Hell 1, that's what it is. Thank you very much. Love.keyPressed takes in a key, and Love will actually pass the key for you, depending on when you actually press a key on your keyboard. It's taking care of all that for you behind the scenes, but it's up to you to say what you want to do with the key. So I can just say if key is equal to escape, call a function called love.event.quit. And I think I accidentally forgot to press tab, and so it got confused with the spacing there. Also, thank you very much to the couple of folks that just followed. I didn't have the list here, but I do now. Thank you very much to Explorer Siraj, GraphSnackers22, and Jerry Blee, if I'm pronouncing that correctly. Hopefully I am. Awesome. So that's how we end up quitting our application. I think I should be able to just test this now if I run my project, which I just did with Command L. I'm using VS Code with the Pixelbyte Studios plugin for Love2D. So download that, and then you can just press Alt L or Command L on your machine, and it will very nicely and conveniently let you run Love without needing to go to your command line or to drag and drop it to your executable. It's super convenient. And also thank you to Echoes2165 for the follow. So we can see here at the top of our window, I do indeed see the word Solitaire. And if I press Escape, it does indeed quit the application. So everything is working as expected. I'm going to do another sanity check. I'm going to say love.graphics.draw. I'm going to reference that gtextures table that I created earlier. And I'm going to reference the cards sprite that we were storing in that table. If you're unfamiliar, tables are just essentially hash tables or dictionaries or objects from JavaScript. They function identically to those with a couple of other caveats. But this is Lua's way of storing sort of arrays or hash tables. They function in a multi-purpose sort of way. So now if I press Command L, we do indeed see all of the cards that were in that texture. Everything is rendering just as one block. Obviously, we don't want to draw the textures as they are in this one block. We want to be able to say, I want to just draw the king of spades or the six of hearts at any given point. So we need to do a couple of things before this is possible. And I haven't written this function from scratch in a little while, so we'll see how effectively we can do this. I typically like to go into util.lua. I like to make a util module for utility functions and say, I want a utility function that will take a texture, a sprite sheet, as it's called, and chop it up and store it as a group of separate subtextures. In this case, they're called quads in Lua, in Love2D. This is the object, the way that they sort of idiomatically reference them. But you might see it referred to as sprites. I'm trying to think of what other words one might use to describe it. Texture area, text area. Well, not text area, but texture area you might see it referenced as. Texture block, texture rect, those types of things. It has a lot of different connotations. But in util.lua, I'm going to probably first write utility functions. And then maybe a function called, I typically like to say generate quads and have it take a texture and a width and a height. And in this case, it's a little bit different, because usually I assume that the texture fits the dimensions of the, oh, well, actually, no. What we can do is we can just say texture width and texture height. And so now in this case, I can say basically g frames, we'll say g quads, just to keep the sort of language consistent. I'll typically create a table called gquads, and I'll say cards. I want it to map effectively to my other texture. I want to be able to reference my texture, and I want to be able to reference the quads that I generate from that texture, all the separate subtextures, the individual cards in this case. So I can say generate quads, gtextures, cards, and we saw earlier that they were, what was it? We figured it out. It was 70 by 95, right? Yeah, 70 by 95. And actually, using these hard-coded numbers is a bad design decision. So I'm going to go to source. I'm going to create a new file called constants.lua. And this is typically what you should do. You shouldn't have magic numbers sort of all over the place. Instead, I'm going to, in here, say card height gets 95. And card, well, rather, typically width goes first. Card width equals 70. And notice that I'm capitalizing and underscoring these variables. This is sort of idiomatic for defining a constant, so something that you shouldn't change. Now, Lua is dynamically typed, meaning that I don't have to say const card width or card height or int card height, rather. It determines what the value is depending dynamically on what it gets assigned to, or rather what value gets assigned to that variable. In this case, it's getting the number 95, so it just knows at runtime that's a number and knows what to do with it, what it can do with it. We'll give you an error if you try to do certain things with it. For example, adding a string to it, it'll give you an error. It'll crash your program. But there is no typing like you might see in C or Java. So there isn't really a way to enforce that we'll use these variables as constants. But by capitalizing them and using an underscore, this is a programmer convention. This illustrates to the programmer that we should indeed not change these variables at any given point in time. So if you see that, typically don't mess with the variable naming. I could absolutely do that. It would just sort of break the sort of implicit handshake that I'm making with myself, which would not be good. But now I can say, instead of 70 and 95, card width and card height. And things are a lot more readable. Now I can tell that I want to splice this texture, this card texture, on my card width and card height, and not some random value called 70 and 95, which had no real meaning prior to this point. So now I actually need to implement the function. Currently, it's an empty function. So I'm going to end up needing to return a table of quads. I know that. And we can go to the love2d documentation, actually, and see what a quad is. So love2d quad. This is important. Basically, a quad is just a rectangle, in this case, a quadrilateral, a polygon with 4 sides and 4 corners, with texture coordinate information. And you could define it as a square. You could define it as a rectangle of longer width than height or longer height than width. And that's what we're doing in this case. We're actually defining quads that are sort of longer, taller than they are wide, because that's how cards are laid out. So we care about where we want to define the corners of our quad, right? We want to make sure that we say, give it the x, y position, but also make sure we say how tall the quad needs to be and also how wide it needs to be. And then we need to offset that row by row in our sprite sheet. And by generating these rectangles, sort of one by one, if we look at the sprite sheet, one by one here, right? By going into this and sort of creating a rectangle here and a rectangle here and a rectangle here, sort of an invisible rectangle, we can tell love2d when we draw, given that quad, just the area defined by that quad, which is really nice. And this is how you get sprites from a compounded sprite sheet, a more complicated drawing that you maybe want to put everything inside of instead of having separate individual sprites, which we could have very easily done here. We could have easily just drawn these individually, the 4, 5, 6 of hearts, etc. The problem is, if we want to downscale all of these, now we have to individually go in and maybe import these into a sprite, divide by 2, resave. It gets kind of bulky. We could automate this with a script, but it's typically more idiomatic in game development, more common to use a sprite sheet. So back to our code, I can say in generate quads, I know I'm going to want a table to return, right? So I can say local quad table gets an empty table. I'm going to return quad table at the end. And local just means this is a variable that exists in this function. Don't make it globally accessible. If I just say quad table, the way that Lua works, this quad table variable will actually be available anywhere in our application, which is not generally good engineering-wise. Very easily could you clutter your namespace, your global namespace, basically all of the symbols that your program is referencing, all the variable names. You could very easily make this very large and very hard to track where each variable is coming from by not using local where you need to. So definitely use local where it's appropriate. In this case, we only want quad table accessible within the context of this function. So we're only going to reference quad table by using local. So let's figure it out. So we need to generate a quad, which is an x and a y and a height and a width throughout our sprite sheet. So I can say local x is equal to 0, and y maybe is equal to 0 as well. This is where we're going to start. This is the pixel sort of right here at the top left. That's where we're going to start our function to splice the sprite sheet. So I'm going to say for y, actually what I can do is say for y is equal to 0 until And how many cards do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 cards. So that's up until it's not going to quite be y times, or it's not going to quite be 10 times 95. It's actually going to be 10 times 95. It's going to be 9 times 95. So what we can say is, in our sprite sheet, we want to say card sheet tall gets 10. Card sheet wide gets. Oh, and actually, I'm realizing an issue here. The issue is that we don't actually have a consistent sprite sheet. We have 5. Notice that we have 5 rows here, but we have 5 columns here, but 4 columns after row 3. So starting in row 4, we actually have only 5 columns. So I think it actually makes more sense to start top, go down, and work our way vertically through the sprite sheet and stop when we get here. I think that makes a lot more sense. And actually, are things laid out in a consistent way? Things are laid out. Wait, are they? No, they're not actually laid out consistently. Oh, that's pretty funny, actually. So we started with queen, king, jack, ace in spades. And it does go down sequentially. And then the joker. And then the queen down here. But notice that instead of the 2 of hearts here, we're actually getting the 2 of clubs. So they actually made the sprite sheet inconsistent. That's funny. And it's going to screw up our algorithm a little bit. So I hate to spend too much time on this, but. And also, another interesting thing is, oh, OK, they only need 1 joker, actually. That's fair. I was going to say they only have 1 joker. Typically, a deck has, I think, 2 jokers or 4 jokers. But I should fix this. The reason that I should fix this is because if I want the algorithm to generate all the cards in a sequence, and I want all of those cards to, I could do this in code. Is it really worth it? It's good design, so I probably should do it. So what I need to do is go into here and not do that, but take a marquee tool, kind of bring this over here, which I think this is correct, and something like that. And then if I Command C this, can I just move this around? Oh, I can. Oh, perfect. I can just move this. So I'll move it over here. Take this, let's zoom in. Bring it all the way over here. Is that too much? It might be too much. Nope, I don't want to actually shrink it. Let's go ahead and do this. Is this correct? I think that's correct. And so now if I move this over to where we have our space, let's move it down over here, right over here. OK, perfect. And then now if I bring this, also Kenny, if you're watching, maybe fix the ordering of your sprite sheet. Love the artwork, but I'm not sure why it's out of order. Let's go ahead and do this. Bring this up here. Mabel P says hello, and Hardy Praj, you can see the size when you select the cards in the bottom status bar. Ah, good point. I actually didn't think about that. This looks like it should be good. This should work. Kajin, thank you very much for the follow. I think that's right. Yes. And Pimi Now, thank you very much for the follow. OK, so we did that. I'm going to save it. So now we should have, I think, a consistent deck of cards. So what I was trying to say before I realized that the sprite sheet was actually slightly messed up, is that instead of going horizontal rows, going row by row, we'll actually go vertically. So we'll start here, work our way down, go here, work our way down. And this way, in our table, all of the quads will actually be in order, starting from, you know what I just realized? The queens are actually before the kings, too. Why is this out of order? OK. That's not worth. Shoot. Because if we were going to represent the cards based on their number, I could do it in code. It's not a big deal. But at least now everything is consistent. So we can use that consistency to do something else. Rifsan, thank you very much for the follow. OK, so we'll worry about the fact that the queens are coming before the kings and the jack is coming before the ace. We'll do all of that in code. We'll resort everything. It's important in Solitaire that ace actually comes after 2. So we're going to do it that way. Instead of having the ace actually come above queen, which oftentimes you can think of ace being more valuable than, I'm sorry, not queen, king rather. We'll worry about the fact that that's all out of order and doesn't match. But everything is now in a consistent state. I think I can quit ace sprite now. And I'm going to basically have my algorithm go top to bottom, left to right. And then when it gets to the 2 here, well, actually, it doesn't need to really worry too much about whether it gets to the 2. But it will have, up until this 2, 1, 2, 3, 4, 5. So it's 10 plus 3. So it'll have 43 cards that we care about. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 53 cards, not 43 cards. I don't know how to count. 53 cards, minus the joker. We don't care about the joker. And I just realized that that actually screws it up too. So it's great. This is the fun part of dealing with sprite sheets programmatically, is you do run into sort of cases like this where you have to restructure your data to fit the problem you're trying to solve, and or write an algorithm that considers the fact that your sprite sheet is messed up and sort of in code sorts everything out. Can we have a 4 by 13 or 13 by 4 sprite sheet? Yeah, absolutely, you could do that. But you want to, in that case, that's on you to sort of manually figure out in your text or in your graphical editor. And so there's a bit of work that goes on you to do that. Now, if you're working with an artist, you can tell the artist, hey, I want to think about my problem like this, so please lay out the sprites 4 by 13, right? Which I would actually want that to be the case. My ideal, the way I like to think about it, is having everything in a row. And so having ace to king going horizontally, that makes sense to me. I can easily parse through that programmatically, generate the tables that I need, and get everything working. And Lince's point, yeah, worry about it afterwards. Just make a lookup table. That's fair too. We can easily do that and write everything in code. There is a merit to simplifying your code by making sure your data is nicely laid out, but we're already spending a good amount of time on that already, so we can make the lookup table and resort everything. So the card sheet wide, we're not actually going to worry. Well, we don't need to worry about it too much, but we'll say it's 6 wide. And so we're going to end up parsing our sprite sheet left to right, 6 cards wide and 10 cards tall. Now, actually, no, not a consideration. There's extra white space at the bottom, but that's not going to matter for our algorithm because we're going to calculate it based on the number of cards, not the size of the sprite sheet, which would cause an issue if we were doing it just that way. So back to util.lua. I'm going to say for y gets 0. Well, actually, for x gets 0, because we're going to do this. We're going to parse it column by column at the top level of our loop. The inner loop is going to go card by card vertically. And so that needs to be the inner loop. So I can say for x is equal to 0, and then x is equal, x is less than cards wide, or what was the name of it? Card width times card sheet wide minus 1. Do. Why is my text editor is being funky with indentation? So what we're basically saying here is I'm going to start at x is equal to 0. Oh, and I want to also make sure my step is card width. So basically, this is a for loop. It's just saying start at x at 0, go up until x is less than the card width times the number of cards wide, so -1. So card sheet wide minus, it's going to times that by card sheet wide -1. So it'll take into consideration all of these cards -1 because we don't care about going past this offset here. We only worry about going up until the left edge of this card because we're going to calculate the width and the height. We're going to add the width and the height to that. So Pim says, hello everyone, thank you for the content. To make it a little bit complicated, you can add some sort of image recognition for the this unordered sprite. That would be fancy. I don't even know if I'm qualified to do that, but that would be very fascinating. The 3 of the club and the heart are swapped, says Babbitt Knight. 3 of the club and the heart. Oh, yes, yes. I think that was the prior point that you were talking about. Yes, correct. And also, thank you to who just followed. I completely missed that. I apologize. That was, did I catch Riffson and Kajin? So apologies if I didn't. But also, Mick G was taken. Thank you very much for the follow. So we're going sort of up until the left edge of the last sprite that we care about. So we're starting at x is equal to 0 up until the cards wide -1. And then we're also in our inner loop, we're going to start y is 0 and then cards tall -1 times card height. So we can say for y is equal to 0, y is less than card height times card sheet tall -1, step of card height, do. Why is my editor doing that today? That's so weird. And then I might need to restart my editor, honestly. Oh, you know what? I did start my editor in JavaScript mode. I wonder if that's causing funkiness. Anyway, or I started it with a JavaScript project. I'm not sure if that ends up screwing VS Code up in this case, but hopefully not. Here's where we actually need to generate a quad in our sprite sheet. So I can say table.insert quad table. So we're going to insert into quad table a new quad. We're going to call it love.graphics.new quad. And it takes in, this is a nice thing about VS Code, is it has this IntelliSense sort of thing for us, which tells us the arguments that new quad takes. So an x and a y, which is going to be xy, and then a width and a height. So x, y, and then our width is going to be card width, and the height is going to be card height. And then that should just work here as we need it to, I think. Oh, and I think the last thing it needs actually is texture get dimensions. For some reason, underneath the hood, when you generate a quad, it needs a reference back to its source image, specifically the dimensions. I don't remember the exact reason why. I looked at the C code for why this is, but you can look at the code. The code's open source for Love2D, so you can look and see if you're curious. I don't remember offhand exactly why that is the case. And this is taking up a little bit too much room, so we can just do that. Now, this should work. If I go over to main.lua, for example, and I pass into love.graphics.draw a quad, so if I say gcards quads 0, rather 1. Because remember, love tables are 1 indexed. It's a very weird thing about Lua, but normally in languages, arrays and other data structures are 0 indexed. In Lua, everything is 1 indexed, just by default. You can 0 index explicitly, but it's not idiomatic to do that. It's more idiomatic just to stick with the 1 indexing paradigm. So, you know, something to get used to as you're venturing into Lua territory. But now let's see if everything is correct. My fingers are crossed that I got this right. Oh, I forgot to reference my util class. So in dependencies, because remember, we're requiring dependencies in main.lua. So anything within dependencies that we require will therefore, by transitivity, get required. So I can say require source/util and card, and also constants. Let's make sure to require that as well. Require source/constants. And that is what just happened. OK. Why is it? OK, I must have hit a shortcut that flips it to horizontal. I'm not sure how that happened, but we won't worry about that too much. I'm not running Lev, am I? Nope. So if I run this, attempts to compare nil with a number, util lua 8. OK, let's see where we screwed up our algorithm. On line 8, Nil with a number. Okay. Card sheet wide, card sheet tall. I have that right. Card width, card height. Is it by chance? Everything is source constants and source util, which is fine. OK, this is interesting. So on line 8, it's saying for x is equal to 0, x is less than card width times card sheet wide minus 1, which is oh, wait. Need to put those into parentheses here. Let's try that. I don't know if that's going to fix it. Compare nil with a number. OK. Live debugging. Here we go. And also, in the event that somebody in the chat caught the bug before I did, I'm going to make sure that I can visibly see it. Fascinating. OK, so for x is equal to 0, x is less than the card width times the card sheet wide minus 1, which is good. Let's, just as a sanity check, let's make sure all of these things are running, maybe. So love dot, or rather, let's print card width and card sheet wide. And because by default you don't actually get print output, like console output in the terminal, doesn't util require dependencies since using variables from dependencies? Do you know increment the counter, or does Lua do it for you? You increment the counter with that last step. So the little bit here which says card width, this is the actual step. Now you could do something like for x is equal to 1 till 10 do. And what that will do is oh, wait. Is that right? Wait, no, hold on. I thought I just had a moment of revelation, but I don't think I did, actually. No, you don't do a condition. That's what's getting me confused, I think. It automatically assumes or at least I thought it didn't take a condition. Let's see. Yeah. No, it doesn't. I got mentally confused about the fact that it just kind of assumes less than. And that was the issue. So what it did was you basically say from 0 up until that point with this step, go up. And you can specify going down, and it kind of does the same thing. It will sort of know that you're looking for greater than or whatever. So this is what I did. I said card width times card sheet wide minus 1 up until that point. And then card width being the step value, which is by default 1. But we made it the size of the cards that we're just jumping in blocks of space. Card width minus, M. Kloppenberg says, doesn't need to be card width ... minus 1. Not card width minus 1, because we're starting at 0. So by offsetting by the card width, we start at the left edge of the next card, if that's what you're referring to. But yeah, no, it was me being silly with my for loops. So I apologize. Pass static variables and see if that passes. No, I think we figured it out. I think it was just an issue with the for loops. So there's actually no condition you need here. You just need to specify the upper bound or the lower bound if you're doing a backwards loop. But in this case, we're doing a forwards loop. So it just assumes less than. Cool. So that works well. So now we can visibly see that we are drawing cards at the right size. So in fact, I think if we were to go here and say for x is equal to 0 up until well, let's say there's 13 cards, right? So here's another thing that we need to take into consideration. Cards in suit, we're going to say 13 because you start at ace and you go up to 10 and then jack, queen, king. So we'll say there's 13 cards in each suit. Cards in the deck, we'll say there are 52. We are going to need a deck class at some point. But I can say for x is equal to 0 until cards in deck do or rather, from 1 until the cards in the deck, because it's inclusive, then I'll say in here x. So now we're saying basically from 1 until 13, including 13, draw each card. And then I want to specify a different x and a y because I want to show all the cards being drawn there. And also, M. Kloppenberg says, got my languages a bit messed up again. Thought the whole statement needed to be within parentheses. Yeah, no, not quite. Yeah, I know. Even I'm today, for some reason, getting my syntax a little bit messed up. It's been, 2 weeks since I coded in Lua, and I've been coding a little bit in other languages, so I apologize for that. But we'll get back on track here. So let's say I want to draw them all sort of horizontally. So I'll say x, maybe, or rather, x minus 1 times card width. And then we'll just say 0 for the y. And if I run this, we do indeed see that we're getting all of the cards drawing from their higher to lower suit, which is pretty cool, or their higher to lower face value. Now, granted, as we mentioned before, there's a slight bug where the queen actually comes before the king, and this isn't helpful. So we're going to need to sort of put this in the right place. And then also the fact that joker comes in the middle of the deck kind of screws up our ordering just a little bit. So we're going to need to account for that as well. So why don't we do that, actually? Should we do that in the deck class? Figure that out using our data structure? We could do that, right? Yeah, why don't we do that in our deck class? Let's make a deck class. So I'm going to create a deck.lua deck class. And then I'm going to say the deck equals class. Now, this isn't syntax that you get by default in Lua. Remember, we need to actually import that library that I mentioned before. So I'm going to go over back to, I think in Minesweeper we had it. So if you saw earlier, look up helper utilities for massive progression. That library, you can get the class.lua from it. I'm going to go ahead and do that. I'm going to copy that into my Solitaire library. And what I typically like to do is, rather than put it with my other source files, I put it in a lib folder. And so here I have lib class.lua. Now, in dependencies, remember we need to also account for this. So libraries typically export all their functions as an object that you can reference by name. So I'm going to say class. I'm going to assign it a global variable because I haven't said local class. This is a global variable called class equals require lib/class. Now, anywhere I can use the symbol class, the word class, and this will refer to the library code that I just imported. And by referencing class here, basically using that class's built-in functionality to use object-oriented programming in Lua, which otherwise doesn't provide it to you in the same kind of way. It has other funky ways of doing object-oriented programming, which gets a little bit messy, in my opinion, a little bit iffy. Especially if you're coming from a language like Python or Java, where things are more classical style. Prototype inheritance, I'm not a huge fan of. But it's hard to avoid, especially on the web. JavaScript is a prototype-based language. They recently added classes in ES6, which is nice. So they are taking steps in that direction, at least. In real life and chess, the queen is greater than the king, says Bavik Knight. I like that comment. The joker isn't a quad now. I think we haven't ignored the joker in quads. Indra, you're correct. We do have the joker in there. So that's what I'm referring to. We're going to need to account for the fact that the joker is just kind of an imposter into our table. Like we need to account for its existence. So what I'm going to do is sort of in this deck class, I'm going to need to instantiate a deck of cards that makes sense. That has all 13 cards for each suit all together. We can make it sorted. We can make it randomized. But we need to ignore the joker, basically. That needs to happen. And in order to have a deck, actually, we need to work our way backwards a little bit. We need to also have a card class. We need to represent what a card is. Because cards have some information that's kind of important to them. Namely the fact that they have a face value and they have a suit. You can have a queen card, but your queen can also be a diamond or a spade or a club or a heart. So these bits of information are valuable, and we need to map this information to our sprites so that when we say we want to draw a queen of hearts, we actually end up drawing the correct card. Or a queen of spades, we want to draw the correct heart, or the correct card. So not the correct heart in that case. That would be incorrect. So let's go ahead and say function deck init. And back to the card, actually, that's important. We need to say, let's make a card.lua class. In here, I'm going to say card class. There's like shadow on the building next to me, and I thought my vision was going wacky for some reason. I'm going to say card equals class. And let's create what's called the constructor for the card class. And some of you who have watched this before might know what I'm talking about. Some new folks might not know what I'm talking about. This is the code that's going to run for each individual card we create. And we know that each card is going to need a face. So we can say face. And let's just say that the constructor will take in two arguments, a face and a value, right? So let's say it's going to take a face and a value. And so self.face equals face and self.value equals value is just storing that information from the constructor into the card itself so that we have a reference to it later. And then I'm going to say card.render. We're going to assume that our card is going to take an x and a y. And another important thing to take into consideration, the cards in our game can actually be revealed or hidden. So we want another value. We want to say self.hidden is equal to, and by default, we'll assume that we don't want it to be hidden because we want to test all of this for correctness pretty soon here. So in addition, I want to draw the card in the right place. Now I want to say love.graphics.draw. And this is sort of where we need to think about how we want to structure our data, our table that takes into consideration the layout of all of our cards, so that we can index into our whatever that data structure is based on what its face might be or its value, right? And so I can envision this sort of as a 2D table actually, and I'll illustrate this in a second. But I'm going to say love.graphics.draw, and I know that we're going to use the cards texture eventually. Right? We know that much. We have the card texture already laid out. That's fine. But the G quads, it's going to be a little different. And actually, let's assume that I'm going to have G card quads as a new table. We're going to actually create this ourselves. And this is going to be a 2D table that I can index into based on face, right? Or I've conflated face and value. Sorry. It should be face and suit, not face and value. Face and suit. So let's assume that my table is going to be laid out such that I can have a face that I index into. So there's going to be 4 tables in my table that are indexed based on whether it's a got that reversed as well. It's going to be indexed into the suit. So the table is going to have hearts, spades, diamonds, and clubs as the 4 top-level tables within that table. So we're going to have one table. Within that, we're going to have, and I'll draw this out actually here in my util.lua. So we're going to have a table that's going to be called, actually, it makes more sense to have this in dependencies. It's going to be called G card quads, which is going to have a face value, or 4 suit tables, the first one of which is going to be hearts, right? Then diamonds. Then clubs. And then spades. And what these tables themselves are going to be in here is all of the actual, those are going to be the actual tables full of the face quads themselves, right? Well, they're going to be face and suited quads. But we're going to lay out such that all of the quads inside this table are the hearts from ace to king. And here we're going to have all of the cards, the diamond cards from ace to king, and all the clubs cards from ace to king, and all the spades cards from ace to king. Therefore, we can index into G cards quads at hearts, and then index into that at the value we want, and get the right card. Everything is sort of laid out nice and cleanly. So this will actually eventually work, just like that. And then I can pass in x and y that we pass into render here. And then this needs to be self.suit is equal to suit. So let's actually clean the data like that and actually make that data structure the way we want to. In this case, I can probably do it in dependencies.lua right here. So what I want is, so let's look at our data again. Let's look at our quad, or rather our texture, our sprite sheet. How did I, OK, there we go. So everything starts off in spades. We know that. So we can say from 1 until 13, I want those to all be added to the spades table, right? And then I can ignore the joker. And so then from 15 until, that would be 28, I can put those into the hearts. And then from 29 until 32, those will be diamonds. And then from 32 and 33 until 56, I think, unless I'm getting that wrong. Oh, I'm adding 13. It should be inclusive. So -1 from all those calculations. And that will be effectively the offset that we need. And by the end, we should, or the last value it should be indexing into is number 53. Because this is a 53 size table. We have just the one that we're skipping, but the last value will eventually be 53. So I can probably pretty easily just do this down here after G quads. So I'll say allocate all proper cards to the right subtables. So, and I could have put this into the generate quads function. I could have made this part of its behavior, but then it wouldn't be, I mean, it's arguably, well, no, it's a general purpose quads function at the moment. If we made it a little bit too specific, I think that kind of defeats the purpose of having the utility function. So if anything, we'd want to make a separate function for this. But we might be able to just do this in code. And, well, actually, we might be able to make a function out of this. So let's say function allocate subtable. And it's going to take in the main table, start index, and end index. Oh, and also we want to say allocate subtable. The first argument should actually be the new table we want to allocate to. So we'll say new table. And so what we can do is say for index is equal to start index until end index. I need to restart VS Code to stop this indentation. It's starting to drive me a little bit crazy. And also, documentation is important. So given a new table, allocate from start index to end index the elements located in main table. Allocate to it from start index to index the elements located in main table. So for index, so starting at start index until end index, we're going to do a table.insert into new table. main table at index. And what this is going to do is it's going to index in a main table at our current index, which we're starting at start index, and just add it to new table. That's all we're doing. We're just doing just an insert, adding it to that table. And so what I can do here is say, and also notice that I capitalized my functions in util. This is a convention I've seen sometimes. It's not really hard set. You could lowercase this if you wanted to. But I typically like my capitalized functions, my utility functions, sorry, to be capitalized just to tell me as the programmer that they are utility functions, that they are meant to be used broadly. They're not quite classes, which classes are also capitalized, but they function in a sort of robust, generalized way. So I can say allocate subtable from, and here is where engineering is important again. So we'll say, where do we want this to be? So spades is first. So spades starts at 1, right? So we can say in constants, spades start is equal to 1, right? That's fine. We don't need to specify the end because we know that after every start plus 12, we get the end index. So that's fine. So I'm going to say after the next one, which is queen, we know that queen actually doesn't start at 13. It starts, or at 14, rather, it starts at 15. So we're going to say, sorry, what was that again? That was hearts. So hearts start is at 15. And then likewise, we have diamonds. Oh, you know what actually we could do? We could make this general purpose. OK, we're more flexible. So I could say spades start plus cards in suit plus 1. There we go. So it's a little bit more robust this way. Will the draw function be in the card class, says Adam. The draw function, so the card class will have a draw function. And then we will reference that draw function from whatever. We'll probably use a place state, so we'll use it from the place state. But yes. Let's save this. So heart start was that plus 1. And then the nice thing is I can actually say, where do we go after hearts? To diamonds. So I can say diamonds start equals hearts start plus cards in suit, which is correct. And then, is that right? That should be right, right? Yeah, because there's 13 cards in the suit. Yeah, that should work. And then finally, clubs start is equal to diamonds start plus cards in suit. So here we have kind of a nice magic numberless way of looking at the problem. We're sort of shifting the start of each of these such that we don't have to write in plus 13 all over the place. We don't have to do plus 14 for the joker. Everything is pretty clean, I would say. So now we're going to allocate all the subtables. So we're going to say into G card quads at hearts. I can say from G quads, because remember, our function signature is such that it expects the new table. The table we're taking the sprites from, or the elements from, this is general purpose. So actually, theoretically, this should work for any table with any kind of data. But we're going to use, in this case, quad information. So G card hearts at, using G quads, we're going to say the start index is going to be hearts start. And the end index is going to be hearts start plus cards in suit. We don't want to do, do we want to do plus cards in suit? No, we want to do plus cards in suit minus 1. Because this, if we do it this way, it'll actually, because it's an inclusive loop, it'll actually go to, it'll add the next card afterwards, after the end of the hearts. And it'll be this way for all of them. So we actually don't want that to happen. We want to -1 off of that. And so now I can say hearts, diamonds, and I'm mapping it to how the layout is down here in the card quads. It doesn't really matter the order. But in here I need to say diamonds start, and then diamonds start plus cards ensue -1. And here is going to be, we do clubs and spades. So clubs. And then let's replace both of these with clubs. And then spades. And then do spades. I forgot to Command D that, so it highlighted the next one. But now, in theory, this should actually be filling this table, each of these subtables, with all of the suited variables from, or suited cards from the main table. Now, the unfortunate thing is that while we have all of the right suits, they're not in the right order. So this is another kind of aspect of solving this problem. So let's see, what would be the best way to solve this? So let's go into here. We know the queen is before the king, so we can just swap those. And it's OK if everything's in reverse order at that point, but ace needs to ideally be after the 2. Well, actually, no, because it should actually be in reverse order. So if we just reverse the table, that would actually work. Allocate subtable. So we want to reverse the tables, and then we want to put the ace at the end. Well, we want to put the ace at the end, reverse the subtable, and flip the queen and the king. And then shift it up. So it's more easy, I think, just to get the right indices and plug it in order. So we might just end up doing that. Ordering is simple. Map the card to a number, key value pair, and sort according to the value. Yeah, no, it is. I think we'll have to end up writing a sort function ourselves. I don't think Lua has a sort function. Does it have a sort function? Lua sort function. I don't think it does. Oh, maybe it does. But it expects everything to be in a table. Does it take an anonymous function that we can use to be the sorting function? In this case, what is f? F is, typically these will take a sorting function. So you can define a function in advance that takes an element. And the table will apply this sorting function to all the elements and allow you to have a very flexible sorting function. You can do this as lambdas in Python, for example. I haven't had occasion to do this in Lua yet, so this is interesting. Let's see if we can actually do this robustly. An alternative order, it says, f. OK, so this order function receives 2 arguments and must return true if the first argument should come first in the sorted array. If this function is not provided, sort uses the default less than operation corresponding to the less than operator. I'm not a huge fan of their documentation for some of these things. It's a little bit iffy. Like, where is the f function that I'm presuming was previously defined? I want to get a sense of what it looks like. Well, I mean, we can worry about the sorting actually. Well, no, because we were going to index it from card to draw it. That's the whole issue that we came across. Here, let's maybe write another function. So we allocated the subtables, which is perfect. And that works, presumably that works fine. Actually, we should probably test that. So if I were to go into, we can test that actually in main. So let's go over to main. And then I'm going to go down here into, for one, cards in deck, I'm going to say G quads at hearts. G, oh, did I call it card quads? Card quads. So at G card quads, I'm going to index into hearts at X, which should draw from 1 to 13. And so this should work. I might have forgotten something. Yeah, G card quads, which is a nil value, which in dependencies is, wait, how is this a nil value? Wait, what? Attempt to index a global G card quads a nil value. Dependencies line 14. Oh, because I forgot to put this in before this. OK, that's my bad. Let's go ahead and do that. And I'll run it. Quad expected got nil. So main line 26, which is G card quads at hearts X. G card, OK, G card quads, hearts at X. Bad argument number 2 to draw. Quad expected got nil. Did we screw something up with our allocation? Because these aren't failing, right? Hearts, diamonds, clubs, and spades. We're filling the hearts, right? Allocate subtable. So as a sanity check, what I should probably do is just print G card quads hearts. And let's just make sure that it's printing out a table. And actually, there's a recursive table printing function that I really like. On line 14 of the card class. Oh, we haven't done that yet, Bella. We're not actually doing anything in the card class. So recursive table output Lua. There's a recursive function. I don't feel like writing it from scratch. Somebody wrote a function that actually, oh, OK. Here we go. So I get a function called dump, which is a nice name. So this is a recursive function that should allow us to just literally dump a table. I'm going to capitalize it just for consistency. And then it recursively calls itself. So I'm going to also capitalize that. Recursive table printing function. And it's on Stack Overflow. So if you're curious to get it, if you're following along, it's here on Stack Overflow. I typed in, what did I type in? Recursive table output Lua, first result. It's like 3 answers down. So right here. So now I should be able to just, per the name dump, instead of print, I'm just going to dump G card quads hearts. Now I can't do this with my extension. I actually have to go into the terminal here. I'm going to go into dev slash streams and solitaire and call love dot. And then there we go. It didn't even dump it. 70, it's printing 70 and 6 though. Are we printing something? I don't remember. I don't think we're printing something. I might have just screwed up. Might have just screwed up Oh, wait, no, that's not possible because if it's a table, it's set to output the curly brackets here as a way of visually illustrating to us that, some people are asking, still using value instead of suit? No, we changed that, I think. Shoot, I apologize for this slight delay in the flow here. But this is programming. So live debugging, which is fun stuff. Let me go ahead and figure this out. So dump gcard quads hearts should be a table, right? We've set this to be a table. If we go into, for example, well, actually, let's do it before and after. So we know for a fact that gcard quads hearts at this point in time is just an empty table. So it should be printing at least a table at that point. So let's try that. It's not printing that. OK, main 26. Is it not even printing? Wait. OK. Hold on. Print sanity check. OK, so it's printing. Why is it printing 70 and then 6? Where did we get that from? 70 and 6. Let's go to source constants and source util. Did I have a print up here? Oh, yes, I printed up here. Right, OK. Let's get rid of those. That was causing me a little bit of uncertainty. And then back over here, let's rerun this. So we're not getting our table printed at all. OK, that's interesting. So is dump not working? Dump. Let's try dumping the value 20. Let's make sure this is actually working. Dump the value 100. It's not even printing 100. OK, so this function is messed up for some reason. Or it's not requiring it. And I definitely saved it. We have a function called dump in here. Yeah. What in the world? Well, first of all, let me just quit code because I am having a slight gripe with the indentation issues I've been having. Let's go over to, let's reload this into VS Code. I apologize for everybody tuning in who's struggling with me at this exact moment, but we'll figure it out. Yeah, Adam says game dev is tough. It's a little tough sometimes. OK. So we're getting sanity check. We're not getting dump. Why are we not getting dump? OK. Oh, wait. Because we have to. OK, so I'm used to it normally printing. We're not actually. It's not actually printing anything. It's returning a value. We have to print dump 100. So now if we go over here, now we get 100. So now if I print, or if I put G card quads hearts, and I run it again, it's an empty. So we're not everything. OK, so we figured it out. The dump function that we copy pasted, it used, and this is why copy paste can sometimes bite you in the butt. But it returns a string. It doesn't output a string. So we figured that out. We're outputting it now, and we're seeing that debug using the binary search method. If you want to elaborate on that, Babak, or you mean find the problem and throw away half of the, try to figure out half the problem? I almost promise that doesn't necessarily always work because you get weird problems sometimes. Unless you're talking about half of the code, put output statements halfway up the code, which, yeah, that's a popular technique as well. So let's get rid of this dump statement here. Let's get rid of this sanity check statement. So we are sane. The sanity check did pass. We are sane. Isolate the half which is not working. Yeah, generally that's what we were trying to do with output statements. Yeah. So we have this now figured out. The problem is that our G card quads hearts table is not being populated with information. We saw that it was an empty table, which is not going to help us much at all. What we need to do is figure out why that's not working. And the reason that's not working is because we're actually not specifying the quad index that we care about. That'll do it. Still has an issue, but now if we dump the output, we do indeed see we have a bunch of quads in here. Notice this. So our table is 13, size 13. We have 13 quads. So that's great. That's all working perfectly fine. However, in main.lua, for some reason, from 1 until cards in the deck. Oh, does it do it that many iterations? That would make sense. Let's try that. Does that work? No, that doesn't work. That's not the problem. Wait. So there are 13. We have 13 quads here. We can visually see that. That's great, right? On main line 26, what it's saying is that this x here isn't actually being recognized. Even though we just saw that, it is recognized. Hearts does have 13 quads. We can visually see that here. We can visually confirm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 quads. So they're definitely not nil, right? Unless, OK, print x. Oh, it's printing 14. OK. Which I did -1, though, and that still caused an issue, right? Wait. What? Cards in deck -1. Oh, I feel like I'm going a little bit insane here. OK, cards in deck. But if we pass in 5, it goes up to 5. Cards in the deck is 13, right? This is a little bizarre. Very clearly, we can see that when I type in the number 5. OK, so here, let's do this. Let's say in main, let's say from 1 to 13. OK, we saw that. Oh, wait, not cards in the deck. Cards in not cards in the deck. Cards in suit. Cards in suit. Oh, man. That's beautiful. OK. Yeah, true Kines. I, for some reason, thought I was doing cards in suit, not cards in deck. I'm silly. I am just silly. OK. Beautiful. That works great. Everything's great. Everything's beautiful. Those are the kinds of bugs that are difficult to debug. Those are the ones where your brain is just a little bit off, and even doing my best to name things well, I just can't think straight enough to discern the difference between a suit of cards and a deck of cards. But anyways, we figured it out. Shorts, doesn't silly describe over 70% of mistakes? For me, maybe like 95% of mistakes. Cryptic says, oops. Yeah, that was rough. I apologize. For those who might have seen that in advance, who are sort of yelling at their computer screens saying, you have the wrong variable name, I apologize. Don't really have much to say. That was just me being silly. Anyways, that works great. So now we can worry about actually putting things in the correct order. Because right now things are not in the right order. If we draw our cards out, first of all, we can see that we do get queen, king instead of king, queen, jack, 10. We get queen, king, jack, ace, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So we need to actually resort our tables, right? And I guess I can put it into util.lua, even though it's pretty specific to this game. So resort the quads of a card of a suited table. So I'm going to say function resort cards, and it's going to take in a table. We're essentially going to just like repopulate another table and reassign it. So this should be pretty easy, pretty basic. So resort cards takes in the old cards, right? And so I'm going to say local new cards is going to be equal to a table. And I'm going to say well, I want to return it. So I'm going to say return new cards. Well, we'll take care of the assignment in our actual dependencies.lua. But it's OK. I like seeing people make little mistakes. We all do it. Yeah, I don't enjoy doing it on stream, but I've embraced the fact that it might happen. When playing with CS50 Pong, I kept getting a nil because VS Code put ball.x instead of ball.x. Oh, I'm seeing all of your code in all caps, or all of your message in all caps. So I'm guessing there's like a lowercase versus uppercase issue in there. But yeah, that's an all too easy mistake to make, I think. Just having the wrong capitalization for stuff. Yeah, sorry, I'm not reading the actual physical chat in the chat window. I had it on, I accidentally put it on stream a couple times already, and I think some folks want their messages censored or whatnot, so I'm going to avoid doing that. But anyways, this table, we're going to essentially take the old table of cards, and we know the order that things should be in, right? So if I'm looking at my actual graphics here, and I apologize that we're not like necessarily getting into the weeds with Solitaire itself, but this is kind of a big facet of game development, is, you know, getting the more boilerplatey stuff, the less exciting stuff out of the way. So, and a lot of this is more lower level stuff too, messing with graphics primitives and whatnot. So hopefully this is of some educational value to some people, but I apologize if you're looking to eagerly get into the Solitaire code. Once this is up on YouTube, I'm sure you can skim forward or whatnot. And this stream is very likely going to be 2, if not 3 parts, some of which will be next week. We might even be able to do like a Monday, Tuesday thing where both of those days are allocated to Solitaire, because I think we're not going to have a Monday, Tuesday stream, but more on that to come and to be updated on the schedule. But we can see here that we have queen as number 1, king as number 2, j as number 3. So we can basically say, we can work in order, right? So I could say, here, what we'll do is we'll make a constants. We'll make a set of constants for this as well. So I'll say pos underscore ace is going to be equal to, and then this is normally, what is this? 1, 2, 3, 4. So that's 4, right? 4. Pos 2 is normally 13. Pos 3 is normally 12. Pos 4 is equal to 11, pos 5 is equal to 10, pos 6 is equal to 9, pos 7 is equal to 8, pos 8 is equal to 7. Apologies for how tedious this is, but this is part of the flow. Pos 9 is equal to 6. Pos 10 is equal to 5. And then pos jack is going to be equal to, and I can just actually say pos j. Pos j is going to be equal to, and I believe this is actually 3. Pos queen is going to be equal to 1. And then pos king is going to be equal to 2. So this is just an ordering, a mapping of the stuff as it was before, as laid out in the Sprite sheet. Oh, Bavik, isn't Tuesday a code review stream? Turns out, unfortunately, David and Brian are both unable to make the code review stream, so it's going to be postponed. And after this stream, we're going to send out a message to express as much and clear all the events off of the calendar. But yes, the code review is no longer going to be next Tuesday. We'll be doing one probably the next Tuesday. And instead, to fill that day, what I'll probably end up doing is something like another game, or probably Solitaire again, if not on Monday too. This might end up actually being a pretty long series of videos, because this is probably the most complicated game that we've implemented yet. Especially if we do like clicking and dragging and stuff like that, I think this is going to be a little bit robust. So expect more Solitaire today, Monday, Tuesday, and code review the next week. And we'll update all the details on that very shortly. And Indra already was asking, we can't reverse the order in the table. The default table doesn't necessarily expect a, it's based on what I was just able to read, it sorts on like number values. And it doesn't, the fact that we're using objects like, the card class, which has a nested value, and they're using quads, and everything's kind of sorted. And to Bavik's point, game specific. For example, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Like, we don't necessarily know what the order differences are between those. We kind of have to do a little bit of manual work here. It's not a very simple, straightforward thing. We could map these all to numerical values and write some sorting function that does it. But at that point, we're spending a lot of time on engineering. We've already spent a tremendous amount of time on this, so I would like to ideally get beyond it. But the way we're doing it here is still fairly well designed, I think, fairly clean. Now, what we can do here is say, one by one. Oh, also, the Careful Explorer, thank you very much for the follow. And did I miss anybody else's follow? I apologize if I did. Professor00, MR Sirkin as well, thank you very much for the follows. Let me go back to here. Apologies. OK, so here in new cards, what we're going to do, or rather in resort cards, not resort cards or resort cards, resort cards, we're going to use this ordering that we just established here, where sort of ace, rather the first one gets the, or rather, new cards. Oh, actually, what we can do is, yeah, we'll just do a set of table inserts. So we'll say table.insert into new cards, old cards at index, pos A. I think that's how I did it. Yeah. So we're effectively going to go through this now. A lot of copy paste, but things are in a bit of a strange order, so bear with me. 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king. And now if we go back to our dependencies here, I can say G card quads hearts equals resort, and what did I call it? Resort cards. And it takes in G card quads hearts. Right? So we're kind of doing it to itself. And then we'll do the same thing here for diamonds. And then the same thing here for clubs. And then for spades. So now we're getting the subtable from the sprite sheet, so splitting into 4 groups, and then we're sorting them. And this would look really nice in a functional syntax where we would have like sort, allocate, generate, blah, 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 sort of like a comped series of functions. But in this case, we're kind of doing it in blocked sequence. But now, if I go over to main, theoretically, these cards should be in the right order now. And indeed, it seems they are. So we have, notice we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen. And you can't see it. It's off camera, but we do have king as well. Yeah, Pimmy now, definitely it would be better to make a good sprite sheet. We are making so much additional actions just to sort our data. This is an important lesson, though, because you're going to get data like this online from a lot of, if you're going on Open Game Art, or if you're working with an artist, or if you're desperately trying to hack together something. You're going to get into a situation where you might not have everything laid out in the perfect way, right? And so the onus is going to be either on you, the programmer, or the artist to do this. And if your artist is unavailable, no, then you're going to have to kind of figure out how to do this in code. So ultimately, you should probably figure out how to look at quads and how they work, and how to sort the information, and also how to use data structures like tables, dictionaries, hash tables to make this work. Virtuoso7, I'm still trying to wrap my head around reading a sprite sheet. So sure, so the sprite sheet is essentially just the, do I still have this running? Whoops. I don't know why that's still running. Occasionally it'll crash like that. But occasionally you'll run into an issue. Sorry, what was it? I just got sidetracked. No, sorry, different train of thought. This is what a sprite sheet is. It's essentially all of your texture information. Sorry, not textual information. Texture information for your game. And the goal of a sprite sheet is to make it so that you don't have to have separate textures for everything. In order to read the textures, it's different depending on which framework you're using. But what you effectively need to do is split up your game, all of your sprites into rectangles. You need to say, I want a rectangle that defines what the queen card is, or what the king card is. You effectively overlay a grid on top of this entire thing. And that's what we did in our util.lua here, up in the generate quads function. So what this function does is it creates a new empty table. And we're going to populate it with what are called quads, rectangles, effectively. And we pass in what we want the texture width and the texture height to be for each quad. And this should probably actually be called quad height and quad width, which I can do just like this. Oh, actually, in this case, I didn't actually do that. I don't think I hard-coded it. But in any case, what you want to do is you want to iterate over your sprite sheet. And what we did is we did it vertically instead of horizontally. But you say, starting at y0, I want to go down for every card. So I want to start at y0, create a rectangle that's the width and height of the card, save it in my table, go down at y level, what the next card height is. So add the card height to y. So now we're actually here, create a rectangle down to this corner. Okay, go down to here, create a rectangle, go down to here, create a rectangle. And when we get to the bottom, I want to say, OK, now we're going to start back at the top, but I'm going to shift x over. I want to make x equal to card width. I'm going to do the same process. I'm going to create rectangles all the way going down, shift over, go all the way down, shift over, shift over, shift over, going all the way down each time, creating a rectangle each time, adding it to my table. And so now we have a flat table of all of the quads in our sprite sheet. Right? So now instead of having to draw the entire sprite sheet, we can draw just an individual card. The problem that we ran into was that our data is a little bit weird, right? We have a queen here, we have a king here. Normally it should be king, queen. We have our ace after the jack. Ace should be at the end. It shouldn't be after jack. So we need to resort everything too. And we need to divide things up ideally by suit so that we can index into the right suit at the right time, right? And so this stream is ultimately more of a lesson on how to actually sort card data and make a card a deck class than anything else that functions well in the context of, I think, any card game, any casino card game. Because you could use this deck class that we're creating now for probably anything. Poker, blackjack. You could spawn multiple decks, add them together. You could do all kinds of different things. But in this case, we're using it just for Solitaire. But the fact that our data was in a less than ideal format means that we have to kind of go through a few extra hoops. We have to jump through some extra stuff in order to, get the aesthetic that we want. And this is not too uncommon. For example, in my game development course, we actually ended up using another pack by Kenny for Mario. Kenny Platformer, I think it should be called. Pull this up here. And this pack is insane. It's a beautiful pack with a ton of amazing artwork. Not pulling up here. I actually have it, I think, locally here on my hard drive on this account, because I use the same account to teach the game dev course, which I know Adam, at least in the chat, has been paying attention to. And the Jason G says, hello, Colton, what's up? Hello, Jason, good to see you again. I remember Jason G. G for Greece, I'm guessing, if I remember correctly. In my J-Harvard account, if I go to dev, in Mario, I think it was, right here. Was it Mario? I thought it was Mario, right? Anyways, graphics. If we look, for example, at, well, so these are backgrounds. And so the backgrounds, in this case, you would need to determine their size, right? This is another example of where you would use quads. 3 rectangles, 1 for each of these backgrounds. Figure out how high the rectangle is. So start at 0 on the Y right up here, and create a rectangle that goes this wide, this tall. Shift down here, make another rectangle that's this wide, this tall. Shift down here and do the same thing. But we got data from this. As you can see, I'm scrolling through these sprite sheets. These all have different dimensions, different textures. In this case, you have doors that are twice as wide as the other ones. If we get to the really fun stuff, and Adam actually probably recently just saw most of this. Let's look at this one, for example. This is crazy. This is a crazy sprite sheet. And I love it. But look at how much effort goes into parsing a sprite sheet of this complexity, right? So you can massage the data all you want to, but as complex as your thing goes, you're going to eventually need to find ways to programmatically do a lot. I ended up splitting this whole section out for the class, so that because these are all consistent. These all have consistent values, but notice that they're all sorted on color, right? So I still have to do some processing of my tables to say, I want to chop all of my metal, or I guess these are snow tiles, out into one table. I want all my grass tiles out into another table. I want all my sandstone tiles out to another table. I want all my terrain ones separate from the tile toppings out to other tables. So yeah, it gets complicated, but it's a valuable lesson, I think, also that this kind of stuff will take time, and it is essential in game development for very complex games. Games like Terraria, which have thousands and thousands of sprites, just imagine what goes on in terms of them parsing their information. And we are just parsing a deck of cards. Like, it gets exponentially more difficult than what we're doing today. But there are ways that you, the programmer, if you're willing to put in the time and energy, can make this easier for yourself. And certainly reordering things, restructuring things, it's a trade-off. You have to say, do I want to spend my time doing artwork, or do I want to spend my time doing code? And as a developer, you might not have the sort of finesse with things like Photoshop or Sprite to do this manually. And you might not have an artist that you can rely on. So an important thing to take into consideration when you're getting into doing sprite-based game development. Separately, though, I do apologize for how long it has taken. I didn't mean for particularly the bug that came up earlier. That was a very elusive bug. But everything is now in the right structure, so this is great. I'm actually very happy we have everything rendering correctly. We have all of our sprites, as you can see, in the right order. Even though King is sort of cut off, we can assume it's rendering correctly. Let's go ahead now and actually go into my card class. Actually, now this should just work. So now a value of 1 is an ace, a value of 2 is a 2. So now I can just index into the right suit and into the right value, right? In this case, not value. And actually, this needs to be self.suit and self.face. So to someone's question earlier, were we still using value over face? We actually were in that particular context. Virtuoso7, I've got to dig into Lua and Love. Yeah, no, definitely. And I hope that that example I was just trying to illustrate helped a little bit conceptually at least. But look up the documentation on quads, for example, which we had up here. Look up the graphics, the graphics namespace right here, love.graphics. Write a simple program that splices up a simple texture into multiple quads. You know, figure out where you're aligning them, figure out where things are cut off, or maybe they're too big or too small. Get your hands dirty that way, and then work your way up to automating the generation of quads like we just did, which we effectively just made a script that just looped over an entire set of rectangles. And you'll develop that comfort over time. But certainly, if you're not used to it, and if you're looking at this sort of automated approach, this programmatic approach, it can be a little overwhelming. So I totally understand. Now that we have the card quads table here in the right order, everything is laid out correctly, we can reference the suit and the face and draw it at the XY that we care about. So now if I go over to main, let's test this card class, make sure this is working. I'm going to create a card here. And I'm going to call this a Queen of Hearts. And the queen is going to be given the value queen. Whoops. Sorry. Hearts, queen. And actually, I'm realizing that I think in terms of the face and then the suit. So I sort of think of the fact that we should have our card constructor take the same sort of thing. And actually, this should be card, not Queen of Hearts. So what I want this to look like is Queen of Hearts, like that, right? That looks nice. This looks very, it's obvious what I'm trying to do with this code. So what I'm going to do is, in my constants file, I should probably say queen is equal to, let's start from the beginning. Let's say ace is equal to 1. 2 is equal to 2, 3. So, you know, bear with me here. We're just making constants to make our code more readable. That's the whole goal of this. 6 is equal to 6. 7, 8 is equal to 8. 9 is equal to 9. 10 is equal to 10. Jack is equal to 11. Queen is equal to 12. And king is equal to 13. So now this is all great. And actually, I could replace all of the... No, these are positions. Those are different. So this is great. Although... I was going to make these refer to this, but that's maybe overkill at this point. We won't worry about that too much. But now I can say, oh, also the suits. We want the suits as well. So let's say hearts. Wait, how did we order it before? It was, it doesn't really matter, actually. So hearts equal to hearts. Diamonds equal to diamonds. Clubs is equal to clubs. And spades is equal to spades. And also, thank you to, apologize, I need to keep this up, PK1 for the follow as well. OK, cool. So we have constants defined. Let's comment these out. So these are going to be all of our suits. These are going to be our faces. These are going to be default positions for faces in the sprite sheet. Starting indices for suits in sprite sheet. And then these ones are all pretty self-explanatory. OK, so this is good. OK, so main. Now we can say something like this. This looks great. We have the constants defined such that we could do something like this, right? So I could actually say Queen of Hearts. And I'm going to make this local so that it's not accessible from within my other modules. This is something you want to take into consideration. Who said that? Pime now. I apologize if I'm mispronouncing your name. You don't care about memory allocations, right? In this case, no. Love2D manages all of the memory allocated for you underneath the hood, so you don't need to worry about it at all. The thing that you would need to worry about is if you had a ton of resources and you're allocating Sprite texture data. Because it's managed for you, you don't necessarily know how much is being allocated, but it's safe to assume that if you have a symbol allocated to a texture data, it's going to be in memory somewhere. And if you have a ton of sprite sheets that are all pretty large, especially things like modern games have many gigabytes worth of large textures, you can run into memory issues. So you want to find ways to avoid doing that, either by loading them and deallocating them dynamically or avoiding having as big of those textures in your game, right? Because you don't necessarily need them depending on if you can compress them in the right way. Fall back to 0. Thank you very much for the follow. So something to be aware of. In this case, we are dealing with a very small texture. This texture is, how big is this texture? It is 71 kilobytes, so minuscule. And we're just loading literally this texture. All the quads aren't loading the texture at all. The texture itself, whenever we call love.graphics.draw, that's being referenced. And the quad is just kind of telling draw which window to draw that same one texture. But there's only one copy of the texture in memory, which is really nice. So quads are very memory efficient. And this is why, another reason why it's more important to have I think the sprite sheet than it is to necessarily have every individual sprite image. You save bits, right? Because you can get your image compressed in a way such that the whole image is smaller than all of the separate images together. You can have it such that your graphics card doesn't need to load different images into memory. It's just you get a lot of savings that way. So good question, though. Now, if I do in here, instead of drawing the card specifically, if I say, I'll also get rid of, whoops, need to no longer print this. We can say Queen of Hearts render at 0, 0. And I don't even need this, actually. I'm just going to say Queen of Hearts render at 0, 0. So now we're calling just the render from our card class. So we're deferring all the drawing logic to that class itself, which we've already wrote in here. We can see that it's referencing the gcard quads table at the suit and the face that it has. And we passed in the hearts and the face and the suit, which is actually in the right order right now. So this is perfect. So now if I run main.lua, we haven't loaded a card into dependencies yet. So let's do that. So require source / card, and then I'm going to do deck as well. And do I care about constants being first? I think I do. Sometimes you'll run into an issue if, for example, card was using constants, or some of my other modules were using a constant. You sort of want constants to be first before all of your actual modules, just in case. Because it does read it top to bottom, and it does a depth first sort of search on every module. So it will load all the symbols from one, and then go to the next one, and then go to the next one. So you want to avoid having references to constants before constants has even been loaded into memory, right? Let's go ahead and run this. And lo and behold, we do indeed have a Queen of Hearts rendering to the screen in the way that we wanted it to be rendering. Which is super cool, right? This works great. Now, the next thing that we want to probably check for is clicking and dragging cards. And we haven't actually done this before. And I haven't necessarily thought too hard on how we would implement doing this, but I think just a simple flag saying whether the card is being picked up or not should work fine. And then we can end up considering whether cards might have children later on. And this is important because if you're familiar with Solitaire, in the actual game, you can pick up any revealed cards, an entire stack of revealed cards, and when you do that, it will pick up all of the cards that are on top of it. So you can pick up an entire stack rather than in one individual card at a time. And this is why I think this stream is going to be several parts, because there are actually a lot of pieces involved in Solitaire, which is great because I think making something fully fleshed out like this could be fun and a good exercise and a good code base to have online later. But just as a forewarning, this might be a rather large project. Now I realize we actually haven't made a Git repository for this yet, so I'm going to do that. I'm going to actually get a Git init, git add everything, git commit. initial commit with cards rendering. I'm going to, oh, I got my DS store in there. We just talked to Bavik Knight yesterday about having dot files or something, or someone else having dot files in their repo. So I should do my due diligence and probably not have one of those in my repo. If we're going to do this right, which I want to do. I hate how condensed this is. Doing everything at 720p makes it a little bit tricky to mess with some of this stuff. But if I do star dot, might need a backslash dot, or I can just do dot ds store like that. And that should work too. And now if I do git commit, git rm.ds store, git add dot git commit remove ds store. And now what I need to do is go to GitHub, actually create a repo for it. So if you're not familiar with GitHub, github.com lets you host source code for other people to collaborate with you on. And they can give you what are called pull requests. Looks like I have one right here. Oh, this is for the course that I'm teaching. If I create a new repository, GitHub is a little bit slow sometimes. It's a pretty massive website. We're going to call this Solitaire stream, like that. Solitaire implemented on stream, twitch.tv/csvideo.tv. Public, and then create repo. Going to copy this URL. Going to git remote add origin that git push upstream origin master. And now if you go to that URL, which I will post in the chat here, just there. Oh, Bavik's saying that was you with the git ignore. Yeah, hey, if we're going to critique you on it, we have to do our due diligence as well. So I am very happy to make sure we're doing the right thing. Oh, right, Bavik's saying we will need one more sprite for the back of the cards. Correct, we will need that, absolutely. The beautiful thing about this is that this is actually going to be very easy to do because we just need to import one sprite. And we're not using any quads on it. We're just using a regular texture. So I'm going to go back to my folder that had that. Do I still have that folder open? No, I don't. That's OK. Let's go over to some streams, Solitaire, and graphics. Shoot, it's not in here. It's in downloads, I think. Is it? Board game pack? Yep, in here. And I'm going to go ahead and go to cars, choose a backing. Let's get a vote on stream. Do we want blue, green, or red? And which design? Do we want the small sort of symbol design, the large pattern design, or the flat design? Actually, plain, dark background, multi-design, line rectangle design, line rectangle with multi-pattern, or line rectangle with minimal pattern. I personally like the four symbols, like this. I don't know if I care too much about the line or not. Well, I guess that's the only one that has the line, so, or the only one that has the four symbols. So my vote is for the small, this small grouping. But I'm color agnostic, so whatever color folks enjoy in the chat, I'm good for. Blue, blue 3. Blue 3 is this. OK, blue 3 we have. Blue multi, green minimal, blue 5. OK, so it's looking like people like blue the most. Oh, no, maybe not. We got a lot of greens. Looks like we're tied blue and green. I should have a poll. I should have like a polling widget on here or something. Green 5. I'm getting a lot for green 5. Green 5 is nice. Green 5, green 5, green 5. Green minimal. I'm guessing this what people are saying is green 5. OK. Red team. Blue 5. Any. Green 5. OK, we got a lot of green 5s. We're going to go green 5. I apologize if that's not the card that you wanted. We had overwhelming consensus, it seemed like, for green 5. So I'm going to go ahead and paste that right into there. We're going to call this card back, like that. Actually, to keep it consistent with the other thing for playing cards, I'm just going to camel case it. So cardback.png. We have to shrink it. Remember, we shrunk all of the other cards. So what I'm going to do is I'm going to open this with a sprite. Going to do a very super simple sprite size divided by 2. So make that 70 by 95. Do that. Save it. Done. Boom. And if I go over to here, if we're gonna test that this exists right now, that this works well. So if self.hidden, then else, and what we can do is say love.graphics.draw gtextures card back at xy. And we have to actually add that to our textures thing here. So I can say card back gets equal to love.graphics.new image graphics card back.png. Run that. So self.hidden is false, but if I change it to true, as by doing this, we do indeed see we have a background on the card. Super nice. There it is. Beautiful. Code an options menu for the card color. Ooh, that sounds a little bit ambitious. Oh, Cryptix is sad. I apologize. Baptic Knight saying green is Master Yoda. I'm not David, though, so I mean, to be fair, if David were in the chat or if he were here programming this, I think that would be the perfect color for him. We're getting a lot of, it looks like window light today. This is interesting. I haven't seen it this bright in here before. Sweet. So we have cards. We have card backings. It's taken us a while to get there, granted, but we've done quite a bit. We've written quite a few functions. We have quite a robust set of things here. Everything is completely from scratch except for the dump. To be fair, we got the dump function off of Stack Overflow, but we won't worry too much about that. Let's go ahead now and think about clicking and dragging the cards around, because this is important. If we want to do anything in this game, it pretty much relies on us clicking and moving cards around, be it from the tableaus to the 4 piles, or from one tableau to another tableau, or from the stock to a tableau. We're going to need to have this functionality. We're going to need to be able to click and drag our cards around. So it makes sense that the card should be able to check for mouse input itself. And the first thing that we want to do, actually, and we'll worry about deck at some point in the near future, but I'm going to say Queen of Hearts update in Delta time. And I'm going to say, we're going to create a new flag on the card. And we're going to say self.pickedup. And we're going to set that to false. Now, if we get the card clicked on, so if love.mouse.button pressed 1, and we actually need to implement this ourselves, it's still doing the indent. Oh, because I'm not typing then. That's why. OK. Whoops. Hopefully that wasn't me. Just let's retype this again. If love.mouse.button pressed 1, then it's still doing it. What is going on? OK, that is irksome. So let's go ahead and write this function that we need to actually get mouse input detected from within functions outside of main. So normally, main gives you the ability to say function love.mouse_pressed button, right? Just like that. And I think it actually technically gives you an X and a Y as well. I'm not 100% sure, but we can easily look at the wiki and say love.mouse and love.mouse_pressed right here. Oh, yep, XY button is touch and presses. So had the order wrong. So XY button. We won't worry about is touch or presses. Presses would be good, though, if we had the notion of a double click, which is common in Solitaire, to double click your cards up into the 4 stalks, or the 4 sections where you sort of build up your full suits, right? But we're not going to worry about that. We're probably just going to use left and right click for this for ease of use. Right click will be reallocate. Left click will be in other interactions, that kind of thing. Cryptic saying my VS Code does that as well. Yeah, I'm not sure. It hasn't done this before, so it's something new, something weird that's been funky. But normally, you're given the ability to say love.mouse_pressed within main.lua, because that's where love2d is looking to see where all of the mouse interactions are taking place. But we want this to be accessible from within the card class. And it doesn't actually give you the ability to override these functions within your card class. So we can instead say, or rather, it does give you the ability to override them within your card class, but if you have multiple definitions for them, it'll cause issues. We'd have to overwrite this in every module that we wanted to override the mouse press behavior, which would cause a lot of bugs. It would be bad. So we want some way to sort of globally make a table of inputs that have registered on that frame and check to see whether the mouse has been pressed a single press that frame. And we can easily do this. Oh, it looks like Night Chris. Oh, interesting. I didn't realize that. That's fascinating. Night Chris S kindly plugged a link to an issue for VS Code where Lua formatting has been bugged. And I recently did just update Lua or update VS Code, so that makes total sense. That's disappointing, but it's a big project. Things are going to slip through, I guess. So what I can do here, if we want to make this globally accessible, we can do is say in my love.load, I'm first going to say love.mouse.keys/buttons pressed equals an empty table. This love.mouse.buttonsPressed, this is something we're creating. This doesn't exist, but we can tap into the love.mouse namespace because Lua is a dynamic language, and I can override it with whatever I want. I can say love.mouse.colton equals some value, and it will work. In this case, love.mouse.buttonsPressed, I'm just creating an empty table here. This will be accessible anywhere in our application. I can make this a global table too. Doesn't matter. I can make this something called global button table and assign it to it. But this is a little bit easier to sort of keep track of and reason about. In love.mousePressed, this will fire every time we press a mouse button anytime. So what I can say is love.mouse.buttonsPressed at button is going to be equal to true. So what this just means is as soon as we press a button, that table will update and have a true placed or at whatever button we ended up pressing. Only on that frame, and the reason it's going to work is because at the end of update, which remember fires every frame, I can say love.mouse.buttonsPressed equals an empty table. So we're refreshing the table every frame, sort of erasing whatever we did flag on the last frame. So it'll only tell us true for the things that did fire this particular frame. And what we want to do to make this accessible is say love.mouse. What did I name it? I called it buttons pressed. Oh, sorry. Was button pressed. This is typically how I name it. I got it confused over here. So I can say if love.was button pressed 1. Now 1 is by default your left click. 2 will be your right click. And then if you have a mouse with a bunch of other buttons, those will get assigned incremental values. So you could theoretically bind love to work with very robust modern mice for gaming and those sorts of purposes. So love.mouse.was button pressed, and then I'm going to look for a particular button, and then I can just return whatever is at love.mouse.buttons pressed at that button. And if we're testing on this frame, and I clicked a left click, and 1 is set to true, and I'm checking for 1, then, well, I can very easily ascertain that I clicked on this frame no matter where I am in my application, whether I'm in a class, a separate class, or even if I'm within main.lua. And this gives me a lot of versatility with checking for input across my entire game. So if love.mouse.was button pressed 1, then I can say self.pickedup is equal to true. And then if I say if self.pickedup, then what I'm realizing now is these need to have an x and a y. So self.x is equal to, I guess we'll just give it a value, self.x, self.y, and then we'll say self.x, self.y is equal to love.mouse.getPosition, which should return an x and a y. Oh man, I even right now tried to preemptively not do the end and just keep this indented and then press enter and type end, and it still went to the beginning of the line. So it is completely messed up. Anyway, we can deal with that. Don't update your VS Code if you're using VS Code and you're doing Lua stuff, apparently. Cool. So now what this is going to do, this is using double variable assignment, unpacking. So love.mouse.getPosition actually returns 2 variables. So I can assign 2 variables to the return of this, self.x and self.y, because it returns an xy tuple, which is nice. And this actually needs to get an x and a y now, which is OK. We can deal with that. Back up here, I'm going to say this gets 0 and 0. And now what I just did here was I actually, instead of setting it to true, I set it to the opposite of whatever it currently is. So self.pickedup equals not self.pickedup means that if it was false, it's true, and if it was true, it's false. So this allows us to toggle that state, which means we can set and put down our card wherever we want to. So let's go ahead and do that. Boom. Doesn't work, which is OK. Why doesn't it work? Card.update. Are we updating? Let's make sure. Oh, you know why? Because we're drawing at xy, not self.x and self.y. Let's do that. Those are just global variables that didn't mean anything. We want those to be the field variable, the member variables of this card object, right? So let's try that again. We do indeed have now the ability to click and drag a card around. And it gets kind of locked to the bottom of the window too, which is cool. And if I click again, I can set it down. So I can set cards down wherever I want to. Now, it's a little bit funky in that I click on it and it kind of jumps to the top, to right at the top left corner of the card. And that's not really the behavior that I want. I kind of would like it to center, if anything. So what I'll do is I'll say self.x, self.y is equal to love.mouse.getPosition. And then I'll say self.x is equal to self.x minus, yeah, we'll do that. That's fine. Self.x is equal to self.x minus card width divided by 2, and self.y is equal to self.y minus card height divided by 2. Now this will center the card on the mouse, which is better behavior, certainly, right? It still jumps a little bit, but it looks a lot better than having it be at the sort of top left of the card. We could calculate an offset, so I could when I click on the card, I could figure out where I am relative to its xy, and then that would probably work. But oh, you know what I'm doing too? I'm actually not even checking for the bounds of the card. So I could actually, I just realized this. I could click here and still pick it up. So we actually do need to check to see whether we're inside the card, so to speak, before we pick it up. So why don't we do that? Dizzy Dazzle is saying this language has so many cool things built into it. I do like Lua. Yeah, it's pretty nice. Set to the middle of the card, says Bavik. Yep, we did. Will you leave it as a toggle click rather than click and hold? Yeah, I'll probably leave it as a toggle. I think it's kind of annoying to click and hold, especially on a trackpad, which is what I'm actually using right here. So I think that's a better design decision, honestly. It's a little easier. Just click it, move it around, click again to set it down. That makes sense to me. Let's go ahead, actually, and if we click on 1, we don't want to just set self.pickedup to equal to not self.pickedup. We want to check to see if it's in the bounds of the card. So I can say local x, y is equal to love.mouse.getPosition. And then I can just say if x is less than or equal to self.x and x is greater than, greater than or equal to self.x, and x is less than or equal to self.x plus self.width, and y is greater than or equal to self.y, and y is less than or equal to self.y plus self. Oh, I just realized self.width isn't the thing, so we'll do card width and card height. Then the annoying indentation bug. In here is where we can actually say self.pickedup is not self.pickedup. So now we're actually verifying the constraints. We're saying making sure that the XY of our mouse is within the boundaries of the card. And this will help us to make sure that we're in the correct spot. So if I click, I can click out here all I want. But as soon as I click on the card, now I get access to it. And I can click it again. So boom, everything is great. Perfect. Fix that bug. Everything is beautiful. Now what we can do, we have about another maybe 30 to 40 minutes of time, I think, before we should maybe wrap up for at least this part one. This part one isn't a terribly robust look at Solitaire itself, but more how to create a deck of virtual cards, how to mess with them. We should set the game board up at least so that things sort of look like Solitaire. So what I'm going to do is I am going to, in main, what I probably want to do actually is have something like a game board class. So new file, gameboard.lua. And gameboard is equal to class function gameboard init. And this is basically going to draw the entire width of our screen. And one other thing I should do is set our screen to 1280 by 720p. So we can do love.window.set mode to window width and window height. And let's make those constants. So window width, we'll make those at the very top of our file here. So window width is equal to 1280. Window height is equal to 720. If I rerun this, we do indeed have a 720p window, which is great. Everything is great. Ashley's saying, so glad there will be a part 2. I forgot to mention that Ashley is to thank for this stream, actually, and this series of streams. She recommended Solitaire to us. So shout out to Ashley for the recommendation. It's a great game. It's going to be fairly complicated, especially relative to all the other games that we've done on stream. But we've done so many fairly simple games that I think it feels appropriate to start diving into a little bit deeper territory. And that's the plan, I think, going forward, too. We'll be doing more games that are in a more complicated sort of domain. Solitaire is not super complicated, but it's reasonably complex relative to something like the typing game, Hangman, things that we've done in the past. This one has a lot of bits and pieces, and especially when we get to things like childing of the cards so that you pick up a whole pile depending on where you click. That's going to be somewhat relatively complex. So it's going to be fun, but stick with it. It'll be a few parts probably. This first part is mostly just getting the card code bootstrapped. So cool. Everything's caught up on the chat there. I'm going to go ahead now, and we have our window all set up. I'm going to define the game board. First thing that I'm probably going to do is say, I probably want to do the drawing. And also, Dirty Dazzle, thank you very much for the follow. I'm going to say game board render. And this is going to do love.graphics.clear. And I want to choose kind of a casino-y color, I think, probably. Something like this. This is a nice little dark green, actually. So we'll do something like that. So I'll say 0. And I'm using a relatively new version of Lua of Love. So the numbers are floating points between 0 and 1. So I'm going to say 0.8, 0, and 1. And that should give us at least a nice green color for the board. And let me go ahead and in main, actually in dependencies, I should probably require it first. So I'm going to say source game board, just like that. I'm going to run it. Sorry, not going to run it. Haven't instantiated it yet. In main.lua, I'm going to say local game board equals game board. Down here, I'm going to render the game board before we actually render the Queen of Hearts card, and then I'm going to run the code. And that is way too bright. So we are going to lower that brightness down to like 0.4. Let's try that. There we go. That's not bad, right? It is a little clashy with the green cards that we chose, but let's bring it down to 0.3. Let's see how that is. Yeah, that's not bad, right? And now I can click and drag this card around, and everything is kind of, we're getting incrementally closer to what we eventually want our game to look like, right? So let's look at the board. Let's look at the Solitaire board at its start and see what we're dealing with. So we can see that we have a few things going on here. Number one, per the diagram, we have our 4 slots for where our finished card piles are going to go. We're going to have 4 card piles we build up from ace to king. And basically, you can just, and they're all suited, by the way. So this is diamonds, hearts, clubs, spades, for example. They all have to be that specific suit, and they have to go in order. So we're going to want those minimally. So why don't we start laying these out a little bit? We can do this fairly easily. I can say love.graphics.draw, or rectangle, rather. And we know that these are going to be the size of the card. So our card size is 70 by 95. So let's decide, we want it to be maybe, what makes sense? Let's do it at, and we can, by the way, eventually come back to this and make it fit the screen nicely and maybe zoom in a little bit with push, make it look a bit more pixelated, look a little bit cleaner, crispier. But love.graphics.rectangle, I'm going to draw some rounded rectangles. I basically want to do what I'm doing in what we're seeing in this picture right here, which is 4 rounded white rectangles. So to do that, all I have to do is say, we'll say main stack placeholders. We'll start drawing them kind of in the left-ish area. So I'll say, I'm going to start at, we'll make this a line rect first of all. I'm going to say, start it at 10 on the Y. And we're going to draw the rectangle at card width, card height, and 10, and then maybe 50 on the Y. And these are magic numbers. We can worry about this in a little bit. And the important thing that I want to do also is round it with this rounding factor at the end, which kind of functions similar to CSS. I forget the exact thing that you can do. I think it's border radius. And then you end up actually shaping rectangles into circles, which is pretty cool. So we're just going to do that there, just like that. And now if I draw that and I re-render the game, notice that we do indeed have sort of a rounded place to put our first card, which isn't going to stick to it. It doesn't matter. There's no logic for our card to actually stick anywhere. But we're laying out our board so that later on we can end up granting functionality to these locations, which we will do. So let's do that for all 4 of them. I'm going to say this one will be at 90, this one will be at 170, and this one will be at 250, right? So now we do have 4 of those slots just set up in the way that we wanted them before. OK, cool. Now what we want to do, there's more things that we want to take care of. This number 2 and this number 3. And the number 2 and the number 3 are actually related. There are certain versions of Solitaire where you draw 3 cards at a time instead of just 1 to act as your next card that you can place down amongst your tableaus. We are going to just do single card draw, like it's done in most digital forms of Solitaire, at least most of the versions that I've seen. And so we're going to sort of just write. We're going to put a placeholder down and then maybe a card to illustrate that. Oops, didn't mean to do that. So we'll make this be the active stock card. And I'm just going to draw this. I'm going to draw this a bit more to the right. So I'm going to make this maybe 400. That's our active stock card. So that works great. And then beside that, I want the stock itself, right? So we'll say this will be at 480, just like that. And then lastly, we want all of our tableaus, which is 1, 2, 3, 4, 5, 6, 7 of these, which they're directly below our other cards. So And I don't know if this is the technical term for the whole stack. I know it, from what I read yesterday, the tableaus are the cards that are on top of the stacks, whether they're, and they refer more to the ones that are revealed. Folks that are more familiar with Solitaire might be able to correct me on that. We're going to make 7 of these. And actually, they need to map up to the ones before them. So I might need to do a little bit of editing of the active stock and the regular stock. But we need 3 more. And we're just going to add 80 to them. This is going to be 330. This is going to be 410. And this is going to be 490. Just like that. Oh, and then also, the tableaus need to be shifted down by at least 95, so 110. So these are all going to be at 160. So we'll do that. 160, just like that. And notice that the cards up above are slightly offset. So what we can do is say 410 and 490, just like that. And now we have an even aligned grid of what we will end up using for Solitaire. So this is great. This looks pretty nice. Things are moving along. And we can, again, move our card, which is great, and set it down wherever we want to. This isn't terribly useful yet because there's no logic. We're just moving a sprite around on the screen. Now, to sort of simulate what things will look like, we can lay things out sort of in a faux manner, I guess. So the game board is also going to have, in addition to its grid spaces, it's going to have active cards. So I can say self dot, and what we'll end up probably doing is self dot tableaus. It's going to be equal to just an empty table. Well, it's going to have a table of varying cards here. And what we'll do is we'll say, we'll actually generate the, we'll generate this. So we'll create an empty table. And then I'm going to create a function called generate tableaus. And the important thing, too, is that we need a deck. And so the deck should probably be visible from outside of the game board, should it? Eventually, the ideal way that we want to structure this is in a state machine, and we can do that on the next stream because we only have about 15 minutes left. So we'll worry about all of those engineering concerns, the state machine and the game states, the various game states, when we, and there's only one main game state, which is play state, and then you get a game over, and then you can toggle back to the beginning again, which is pretty easy. So we won't worry about that too much. Now, we could make everything theoretically accessible from the game board class and sort of have that be the container for everything. Do I care about that? I guess it makes sense. Yeah, we'll do that. So in that case, it's going to have a deck. And the deck is going to be instantiated like that. And generating tableaus is going to end up basically going through our deck, drawing random cards, populating everything, and setting the rest of it in the stock, which we saw earlier. So basically, going through these piles here, flipping a random card, 2 random cards, 3, 4, 5, 6, 7 random cards, put the rest here, and then we draw 1 card at a time from the deck and reveal it, and it gets put into the stock here, right? And we get to manipulate it. So we should keep this into consideration. This is pretty easy, I think. Having everything here in the game board, I think this makes sense. So, and this is all OK here. And actually, what we can do, I can put all of this in its own function and call self draw background. And the reason this is sort of compelling is because all of this code is essentially just the background color and the grid outlines. And we can just chunk it out into one thing. We will be drawing all of the cards at some point within the game board as well, so we don't really need to conflate multiple things in one area. We can function it all out and just call the functions as we need to. Makes it a little bit more readable, more maintainable. Cool. Let's worry about the deck, because we haven't actually done anything with the deck. It's an empty class. So what we should do is make sure that it generates all 52 cards, which it will, and then randomizes them. So we will flatten all 52 cards. So we'll say self.cards is going to be equal to an empty table. And then through each suit, which we put in our, which we had in our blah, 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 dependencies down here, hearts, diamonds, clubs, and spades, we have the G card quads. Actually, no, we don't even need to do that. What am I thinking? No, we can. This is fine. No, this will be easy. So we say for I is equal to, well, actually, no, it doesn't work. We can't iterate over the, we'll just say for, oh, we can do this. For I gets 1 to cards in suit, not in deck, in suit. Don't make this mistake. It's a minor thing. The mouse pointer set to the center is blocking the hidden card design. Oh, yeah, a little bit. That's OK. We don't really care about it right now. We care because we're going to see a bunch of cards sort of laid out all together at some point. So that's fine. It's OK. For I is 1, for the number of cards in suit, do. I remember when you could indent here, and it would actually take you inside the loop. Now it just takes you to the left edge. So it is really messed up. We'll say table.insert self.cards. 52 over 13 says fulfilled gaming. You can do that cool card flippy thing when you win. Cryptics. I'm not. I've seen a couple of things like that. I'm not 100% sure what you mean. And RIFBR says, could you use a while loop instead? You could use a while loop anywhere you can use a for loop. I generally think better in this problem using a for loop. So I don't think a while loop is necessarily useful. I think of a while loop more when you don't know when something is going to terminate. If you know when something is going to terminate, I feel like you're at a bigger advantage letting a for loop maintain the flow of the loop rather than using a while loop. I feel like it's just safer and generally easier to reason about than a while loop. While loop is good for something like user input or something like that, when you don't necessarily know when something is going to end up completing. So we're going to insert a new card in our deck for 1 in every card in suit. And we're actually going to do 4 of these. And we're just going to insert a I card of hearts, I of diamonds, I of clubs, and I of spades. And so now what this is going to do is it's not random at all. This is putting all of our cards in a flat list of 52 cards, which are all sort of in order of every face card, but all 4 suits. So it's going to give me all 4 aces, all 4 twos, all 4 threes, all 4 fours in order until all the kings using this particular loop. So once this is all done, we do want to shuffle the cards. And function deck shuffle. There was a pretty nice algorithm for doing this. It's been a while since I've seen this. Fisher-Yates shuffle. Yeah, I think that's what it is, right? Puts all the elements into a hat. It continually determines the next element by randomly drawing an element from the hat until no elements remain. Oh, I see. OK. So we could do something like that, yeah. So what we could do is say, essentially for what we would do is say local What would we want to copy all of these? Could put them into a hat. We could do random, but then that doesn't end up. You end up in a weird case where you have a very sparse deck, and so your algorithm is very inefficient. It's better to take the element from the base table. Oh, we could do that. Yeah, we could do that. We could say local local base table, base cards is going to be equal to self.cards, right? So we have a reference to self.cards. And then we're going to say local new cards. It's going to be an empty table. We're going to assign self.cards to new cards. So eventually the data that was being held by self.cards before is going to be memory collected, garbage collected. It's going to be gone, right? So what we can do is say for I is equal to cards in suit until 1, do another thing we're going to need to do, if we're going to use randomization, what we should probably do is say math.randomSeed os.time. If you're unfamiliar with this, basically this is seeding our random number generator with the time, the current time in milliseconds since 1970, which is always going to give us a very big number. And this big number influences our random number generator. New shuffle is nice as well. Not sure for this purpose, but I've used it somewhere in an algorithms course. Gotcha. This duck slit says, what are you doing? Yeah, we're making solitaire. We're not quite doing a super ton of solitaire, but yeah, it's going to be, we're making progress. We effectively just have our board and a random deck of cards and the ability to click and drag cards around and not really a whole ton of game logic yet, just given the complexity in getting a deck of cards working well and organizing it, sorting it by suit and value, and in this case, getting a shuffle set up. This is a kind of a lot of the thing you have to do with a lot of casino-style games is just making sure your card system is working. If you're using chips or some other type of system, it's the same deal. But what we're going to do is I can say table.insert into new cards, base cards at math.random at the length of base cards, right? So this is cool. This is effectively putting a new card, or rather inserting a new card into our new cards, getting a random index into our base table of cards. But we can do this in a nice, clean, algorithmic, not super random way where we're looking at sparse entries and sort of crossing our fingers we get everything done. If we say base cards at index I is equal to nil. Because if you set something to nil in a table, it'll actually bring up or actually I think we need to do table.remove. Base cards. You can do nil as well, but I think these both function identically. Table remove base cards at I. Or not I, at, this is, yeah, we need local random index equal to this. So that we can use it afterwards. So we can actually clean up our table. Let me verify that that's true. I believe that that's true. Table remove in Lua. Yeah, so you can give it an index. Cool. And I believe by default, table.remove will actually remove the last index in the table. Is that true? Yeah, last element of the array. if you don't specify an index. Table.remove will work that way. In this case, we're specifying that we want to remove that random index that we plucked off. And so what that's going to end up resulting in is that this math.random, given this length of base cards, will actually be one smaller. And so it won't actually try to index outside of the array, because the table is actually going to fit back in to fill that space. So this is nice. This is super convenient. And at the end of this, we're going to have this new cards. It's all the shuffle cards of our previous deck. And it's going to get reassigned to self.cards. So the prior data structure is going to be forgotten, effectively. Now, if we test this, let me actually render this a little bit. So I'm going to say deck render. I'm just going to render the first 5 cards just so that we can verify that it's rendering appropriately. I'm going to say for I is equal to 1 to 5, love.graphics.draw at self.card, or rather g textures cards self.cards I dot here we go. Do a g card quads at self.cards I dot what is it, face suit, and then at self.cards I dot is value, right? What was it? Oh, sorry. Suit and face. OK, let's actually bring this down to the next line so it's a little more readable here. And let me go into game board. Let me go ahead and are we calling shuffle on ourselves? We are, right? Yeah, we are calling shuffle. So the deck, when it gets instantiated, it should be shuffled right off the very bat. So I'm going to, in here, say self.draw, self.deck render. And I realize I didn't specify an x and a y in the deck. So I'm going to go over here and specify that this should be I times I minus 1 times 80 and 50. That's fine. Right? Does this work? No. Deck on line 36. OK. G car quads self.cards I. OK. Do we have self.cards, right? Yeah, we do. Self.cards I dot suit. And the suit and the face are both working, right? Miss anything? Maybe we should have caught up on the chat. You wouldn't cause each card to be represented by only one int, but sure, this method is very intuitive. Ah, yeah. Fisher-Yates shuffle, yeah, Newth shuffle, I guess they're all the same thing. Don't know. I've seen the Fisher-Yates shuffle before. It's been a while since I implemented it, so I had to look it up on Wikipedia again. But yeah, it's a pretty simple algorithm. I've messed up something here. I'm not entirely sure what I've messed up just yet. Let's look and see. So we're doing the face is there. Right, OK. And then the suit is good. OK. So let's make sure that both of these values are correct. And this is correct. Let's try this. Let's run it from the command line. OK. OK, so this is actually a nil value. Self.cards at y.suit is a nil value. OK. So what if I just print that, and I just print that? Will it still work? Oh, interesting. So the cards are nil. And why are the cards nil? So is our shuffle algorithm messed up then? Let's dump the cards and then exit. Can I exit like that? Love.event.quit. We'll do that. OK, so we're going to dump the cards and then quit just to see what it looks like. Wait. Self.cards. OK, so self.cards is getting an empty table. Interesting. So if I do print dump of base cards, what's base cards getting? Love.event.quit. OK, so it's getting all of the base cards. OK, that's fine. OK. And then new cards. And then table.insert into new cards, base cards at random index. OK. Is it maybe deleting it and then the reference to that object is therefore getting OK. To be a little bit safer, here's what we're going to do. I think what's happening is it's maintaining a reference to the card in the other table. That's getting set to nil. And so the reference within our new cards table is actually getting set to nil. And in Lua, anything set to nil in a table just gets deleted from the table. So we're getting an empty table this way. So instead, what we'll do is we'll figure out what the card suit is, right? So we'll say local card is equal to base cards at random index, right? And then we can say local new card is going to be equal to a card that gets the value of card.face and card.suit. And then in here, well, we'll say 0, 0. And then here, instead of this, we're going to add new card to our new cards table. And then we can remove that card from base cards. And then this should fix the problem, I think. Let's try this out. First, I'm going to get rid of these print statements. Run the code. Ooh, dec39, reference and nil value still. OK. Let's dump self.cards. I need to run it from the command line. OK, so here's self.event. OK, wait. Oh, wait. Hold on. We're getting 13 cards. Wait. Why? Wait, what? We're only getting 13 cards? Shouldn't we be getting 52 cards? It's always 13? Looks like it. Which looks like one suit of cards. Oh, self dot. Yeah. OK, that's fine. That should be OK. We're still getting a group of cards. We're not getting the full 52 cards, which is kind of confusing. Oh. Yeah, you're right, Bavik. Cards in deck when randomized. I'm getting these two confused all day today, which is beautiful. All right, so that's fine. We don't need to dump this anymore. I don't think this is going to fix it. We're still having this issue. So if we run this, we can see that we are, oh, we're still getting 13 cards. Really? Really? Oh, because we're not dumping anymore. Right, yeah. Dump self.cards and love.event.quit. I keep forgetting to run it from the command line. OK, so it's still 13 cards. OK, that's weird. So for all the cards in the deck, which is 52 until 1, we don't even need base cards, actually. We can use self.cards. This is acting as a proxy for self.cards. So we'll just say self.cards. So we're doing self.cards. We have new cards. Self.cards is going to get reassigned to this new cards table. And we're actually instantiating a brand new card here instead of using a reference to the card that we are referencing from self.cards, which should be preventing the nil reference issue, which we were seeing before. Self.cards is equal to new cards. OK, random index. OK. We are calling table.remove on random index. I'm confused why. So we dumped this before. We dumped our self.cards, right? And it was all 52. Oh, no, it's only 13. OK. Why? Wait. Why is that only 13 cards? Self.cards. For 1 until the card's in the suit, right, which is 13, we're adding a card of each type to self.cards, right? That is whack. Oh, wait, are we doing a -1? Oh, I see what you mean. Sorry, Kayabunga. I think you're right, actually. However, I'm still not sure why. Whoops, not minus space 1, -1. There we go. Let's get rid of the event.quit and the dump here. Let's get rid of this dump. OK, there we go. So Kayabonga was right. It was a stupid -1 issue. So thank you for bringing that to my attention. I'm surprised I didn't catch that. Damn. So we have 5 cards rendering. Now the issue I have is that this didn't seem to be rendering 52 cards. I'm just going to make sure as a sanity check that this is actually rendering 52 cards, because I thought it was before. Could have sworn it was. 13 cards. Why are there only 13 cards here? OK, so cards for 1 and every card in the suit, right? I have hearts, I have diamonds, I have clubs, and I have spades. That's 4 cards, right? 4 times 13 is 52. That's weird. Am I doing another stupid bug here? Does dump work without print? No, you have to print it out. It returns a string. I struggled earlier to figure that out. Should be print dump. Oh, yeah, OK. Actually, if that was literally my mistake, I'm going to be very sad. Yeah, that was my mistake. I'm very sad. This whole time I actually was like, oh yeah, you need to be printing dump, duh, like that's obvious. I'm not even doing it in my source code. Man, today has been beautiful. All right, Cool. So that is working. Everything is great. Everything is perfect. Where am I triggering the other print dump that's printing the 13 cards, though? Because that I'm a little bit confused. Oh, it's here. This is what was printing the whole time. Silly me. Awesome. There's 10 cards. Jack, 9, 8, 10, ace. They're all the same because they are being instantiated before math.randomSeed is done, actually. So this we're going to put way up here. And now there are 5 different cards. And we could keep running this over and over again. Thank you, everybody, for sticking with me. That was painful. I apologize. Yeah. Lots of today's it's a troll game that we've been implementing today, and it's been a ride. It's been a journey. This is going to be a long journey. Whoops! I almost hit myself in the face. It's going to be a long journey, but we're making our way there. It's been over 3 hours now. We have a board. We have a random card deck. We have the ability to click and drag cards around, which is pretty cool. I'm actually pretty excited about that. I think that's awesome. These random cards, they don't have their update function being called, so I can't actually click on them and drag them around. But that'd be pretty cool. You can envision the buggy behavior if I were to click and drag this card over here and then click this. Both of those cards would then get picked up, so it can get a little bit messy. But things are moving in a good direction. Next time we do Solitaire, we are going to set up the tableaus. All of the cards are going to be laid out. So 1, 2, 3, 4, 5, 6, 7 cards. We'll get the stock implemented with drawing features. That'll be pretty easy to do. We'll also be able to implement the idea of stacking cards in our stocks. And probably the most difficult thing that's going to be on the horizon will be picking up stacks of cards that have been revealed face up. And making sure that we also add to the tableau in a sequential manner and things get gridlocked to a specific area. Checking for our click handlers on the top edges of cards because we can click on, not just the card itself, but also cards below it and cards that are just partially revealed. So we're going to want to sort of check for that too. So there's going to be some sort of a z-index issue that we're going to need to take into consideration. But that's actually not too difficult because you can just basically iterate through the tableau and check for, iterate backwards from the tableau essentially and check for cards being clicked on or whatnot. So pretty feasible, I would say. Why do we add -1 to the loop, says Indra-Ready? Because we're actually starting at 52 and working our way to 1. If we go back to the deck, which is down here. So cards in deck is 52. It's going to 1 inclusive. And if we say 52 to 1, it's by default checking for checking to go up and checking for less than. If we say -1, it's checking for greater than and going down. So that's just how Lua for loops work. It was a subtle bug that I missed, but some folks kindly provided the answer in the chat. So thank you for the folks that did that. And the true kinese is saying it goes from 52 downwards. Cool. That's it for today's stream on Solitaire. We didn't get as far as I would have liked to get, but we made good progress. We covered a lot of ground. We did a lot of kind of low-level stuff, actually, which is important for sort of card-based games like this. There's a lot of logic that goes into it, making sure everything fits the system. I'm going to make sure everything is on GitHub. So if you want to tinker with everything, game board, cards, clickable, decks, shuffleable. Whoops. If you want to tinker with the code base, definitely by all means do so. It's here on my GitHub account, which I had somewhere, which I don't have anymore, interestingly enough. Let's go ahead and go over there so I can paste the link into the chat really fast for anybody who's tuning in still and who wants to add their own features before next stream. It'll probably be Monday, I'm thinking. Might be Monday, Tuesday. We'll see if the next stream still isn't enough time to implement everything. But let's go ahead and I just added it, so it should be on my account or on my user. Oh, I'll just implement. I'll just do this. Solitaire stream. There we go. I'm going to copy that link. I'm going to go over here, paste it in the chat. So anybody who wants to add their own features, I actually recommend that you give it a try. Let me know on the next stream if you do and you have any particular way that you approach the problem. I'm going to appreciate that cryptics, the victory animation. I can't pull it. Oh, I can pull it up actually. We'll do that. Let's try that. Oh yes. I mean, it's doable, but that's definitely very much a nice to have thing. So maybe we'll cross that bridge when we come to it. They, in this case, are not updating the screen after they draw everything, which is how they get this effect without incurring a tremendous amount of lag. But I'd also have to figure out how in Love2D to disable the per frame refresh, because that would be a way to do it. But in any case, that was Solitaire Part 1. We will go ahead and cut to this screen. I'll see if anybody has any last questions. And if not, definitely tune in tomorrow for our first time having Emily Hong on stream to cover web scraping. So if you're unfamiliar with web scraping, basically using a script to parse a web page's contents and or parse a bunch of web pages' contents using recursive algorithms, using what are called web crawlers or web scrapers, which basically just recursively follow links within HTML pages and analyze the contents within them. It looks like we have Boost Debugging says Apple Club. Yeah, kind of. Is Swift worth learning for the next 10 years? Probably. I'm not too involved in that space, but it seems pretty popular amongst people developing iOS applications and whatnot, which is still very, very much in vogue. Looking to React Native, I'm not sure if that's still as in vogue as it was last time, but Bavik says, what language will web scraping be? I think in Python. I'm not 100% sure. I don't think Emily specified, but I would assume Python. And probably Beautiful Soup, which is a really nice scraping library for Python, and I've used it myself. It's actually pretty nice. Why are the Twitch descriptions basically empty while YouTube has some explanation for the streams? That's a good point. I should start adding all of that information to the Twitch stream. So actually, thank you for bringing that to my attention. I didn't actually consider that up till now. I'll start populating those with information as well. So good point. Good thing to mention. Thank you. And Vavik is saying that reminded him of the old Windows dragging. Yeah, because I don't think they had a refresh on the monitor for as often. Vavik says, I have a project in mind that requires web scraping. Nice. Yeah, I'm interested to take a look at it. I've done very light web scraping in the past, many years ago, but not anything recently. So yeah, can I contact you for an idea, says Boost Debugging? Sure, send me an email, cogden@cs50.harvard.edu. Trukini says, also reminder, join CS50 Discord and check out strawpoll.me for polls. Ah, good point. I will take a look at that. Thank you very much. I want to sell it to Intuit or any taxes. If it's financial in nature, Boost, I probably won't have any advice for you. So I would maybe not ask me for financial advice. Maybe if it's coding related, maybe, but nothing related to finance. Which day for Solitaire Part 2? Says WWW. I think Monday, almost certainly Monday, and probably also Tuesday. We were originally going to have a code review session on Tuesday, but that has been postponed. So Monday and Tuesday will probably both be Solitaire parts. If my forecasting is accurate, this looks like it's going to take a couple more streams to fully implement. So I would guess Monday and Tuesday. The stream will be updated. The schedule will be updated today. So all of that information will be finalized, and you can plan your schedule in advance. All right. With that, thank you all for tuning in for Solitaire Part 1. Thank you, Ashfaq, for the kind words. We will see you tomorrow for some web scraping. Enjoy your weekend after that, and we'll see you also Monday and Tuesday for some Solitaire. Enjoy the rest of your day. See you tomorrow.